Let's make a 2D platformer from scratch in Godot 4. I just launched Godot and have my project manager. I've got a whole bunch of projects that I've worked on for videos and my own projects. Yours might be blank. Yours might have other things you've done. Regardless, we're going to go over here, click New Project. And then we're going to name our project 2D Platformer. You can name it whatever you want. If I wasn't making this as a video, I would call it Devil Boy, because I think that will be thematic with the sprites we're going to use. But place it where you want it. You can browse. I know exactly where I'm going to put mine. So, put it wherever you want it. Obviously, don't put it in a screencast folder because you ain't making the screencast, right? Click Create Folder if you just typed it in. These have to exist for Create Folder to work. But again, you can use Browse. Then we're met with our first sort of Godot bit of a choice. Our first choice in the game of Godot, which is which renderer to use. You can do Forward Plus, that's advanced 3D graphics. Well, we're making a 2D game. You can do Mobile, which supports desktop and mobile. It's for less advanced 3D graphics. Fast rendering for simple scenes, that's pretty good. Compatibility, fastest rendering of simple scenes. Supports desktop, web, and mobile. Least advanced 3D graphics. Well, we're not making a 3D game, so I think compatibility is great, especially for 2D projects. There might be other reasons not to use it, but from as far as my knowledge is I choose compatibility unless I'm making a more advanced 3D game. Click Create and Edit. That will create your project and open it in Godot. And you can see the name of your project here, and you're met with this screen. We've got a lot going on, and I think by following and watching, you'll catch on pretty quick. You're first greeted with this 3D view, which is up here. We're not making a 3D game, so you can just click to 2D, and you lose the Z-axis, which is nice. And now we have a Y-axis, an X-axis, and we're feeling good. What else should I show you? Over here, we've got the scene view. Scenes are different views into your game. The main menu is a scene. Level 1 is a scene. Level 2 is a scene. Settings menu would be a scene. Those are all scenes. And then even like objects within your game, like your player, gets created into a scene that we load into other scenes. So scenes are very important, foundational part of Godot. And don't worry, we'll make our fair share of scenes. Down here is the file system. Godot makes it really easy to view the files in your project, and here I've opened them in my Finder. It would be Explorer if you're on Mac, or on Windows. I'm on Mac, and you can see we're at the path I created. We have Project Godot, and then we have an icon that Godot gives us here. Over here's the inspector. We'll get to that soon, and in the middle is our workspace. So let's start by clicking Add 2D Scene, and that created our first scene. But we haven't saved it yet. You'll see up here it says unsaved. Let's start with the main menu. Boring stuff, but I think it'll really illustrate a lot of the important parts of Godot before we get into gameplay. So I'm going to press Command S, you'd press Control S if you're on Linux or Windows, and save main menu in our resource file, which is our project directory. And TSCN is the default scene name for Godot scenes. I name things snake case, so lowercase with underscores to connect them. Looks like a snake. Click Save, and then now you'll see here we have main menu TSCN, open it in File Manager, and we have our scene there. So we just created a file. You're not often working from outside of Godot, except when you're importing things. So that is what we have there. Now, our main menu scene doesn't have a whole lot going on, but that's okay. Let's click this triangle here, the play button. It says no main scene has ever been defined. Select one. You can change it later in project settings under the application category. So this says when you launch our game, which scene should be displayed. We want it to be our main menu, so we just say select current. Godot launches. You can see the title of our game here, 2D platformer, and an empty screen. So it begins. You can just close that and it ends it. But another nice thing is you can just keep it running. And most of the time, unless you change some fundamental things, Godot will go and automatically reload it as we make changes. So let's see that in action. I'm going to just click back here, but that game's still running. We'll switch to it in a second. I right-clicked, and I'm going to do Add Child Node. You can also do the plus sign here. Do the same thing. Also, Command-A, Control-A does the same thing. And this brings up our node view. We're met with another decision tree in Godot, which is what are nodes and how to add them. So if scenes are collections of nodes in a tree format, so tree means that you can have multiple children and they can have children, and you can group them together that way. And you'll see there's a whole bunch of them. But here's what I want to tell you. You don't need to know like 70% of them, right? Only 30% are the ones you're going to use, and you're going to use them all the time. So don't worry, it's okay. We'll go here into canvas item. That's something that's drawn on the canvas of our game. And we'll expand node 2D, node 2D. And these are the ones that we really care about. And you'll see these will be things like animated sprites, things that have physics like our character body. But I jumped the gun a little bit. What we actually want to do is go into control. And we're going to add a label. A label is a way to display text. So you just select it and click create, and you'll see now our main menu has a child node called label. And over here in the inspector are a bunch of properties about it. Click into text, and you can type something in. I'm going to type in 2D platformer because this is going to be the title of our game. Double click the label here and just rename it the title label. That helps you keep organized and see when you're working with the scene what it's named. And just drag it kind of to the center. There are ways to precisely center something on the screen, but let's not worry about that now. Just know you can add it and drag it. And then let's actually go back to our running game, and you'll see 2D platformers there, but it wasn't centered. So sometimes you might have to rerun your game, but now you'll see it centered. If we drag it, it moved there. You might not have noticed that. Drag it some more. Move. So sometimes you gotta, like when you add new nodes, you gotta rerun your scene or your game. But for the most part, you can just move it around and change it and just adjust it till it feels right. That feels pretty good to me. If you change it here, just add an S at the end, it updates it there. Let's look at a couple other things. We could make the labels with the full width of the game, and then we could say horizontally center it. That's one way to center something. It's kind of a funny way to do it. But you can change text alignment. Good to know. What other things are relevant right now? Let's go to theme and click type variation. And Godot comes with a few out of the box. And let's make it a header large. So that will make it bigger, which is just nice. You know, it implies this is the title of our game. This is what matters. And yeah, we're getting there slowly but surely. So in the main menu, we're going to make it so that you can start the game. So I've selected add a new node, and you can actually type in up here what you're looking for, which is really helpful when you're trying to find something. And we're going to add a button. And this button is going to be called Start Button. So rename the node there and change the text to be Start. You can see this button's here. We'll drag it to the center. Just click and drag it if I can do it. There we go. And we'll just approximately put it in the center of the screen. Go back to our game. It's not there, right? Sometimes when you add a new node, you have to rerun the game. And you can actually hover over it and click it, and you'll see nothing really happens. So we've got our main menu scene. We've got a label node. We've got a button node. Now let's dive into a little bit more complicated topic, which is having parts of our game, nodes of our game, receive some sort of action and then cause something in our game to change. And this is where we'll start to introduce coding. So when you have a node selected, you have the inspector, which we've dived into a little bit here and there. You can click this other tab called Node, and you're greeted with another sub-tab called Signals and Groups. Don't worry about groups yet. Let's focus on signals. Signals are events. They're an event system in Godot. So when something happens, it allows us to trigger code that runs. And you'll see here, button, which is what we added, has 4 signals associated with being a button, and then it has some other ones associated with other parts of its node that it inherits from. We're not worried about these other ones. What we're really worried about is pressed. And you see this connect button? If you click it, we'll see this pop up and it says scene does not have any script. So it can't be connected to any code because there's no code. So what we need to do is attach a script to main menu. Click this button up here and it brings up this new dialog for attaching a script to a node. A script is our code. That's where we're going to type in program. You'll inherit from node 2D because main menu is node 2D. We'll just use the default template, that's fine. And we name it, we'll keep it snake case, and click create. This opens up and switches to our script editor up here. You'll see that because it's blue. If we click 2D, we're back to the 2D viewport. Let's click back to script, and we've got a few things going on. We've got a file interface for working with the scripts. We've got mainmenu.gd, which is the file we created, and that corresponds to this one down here. So you can double click this to open it. You can actually double click, if you double click a TSCN, it doesn't switch back, so you just have to know that in advance. But let's focus on this. We've got extends node 2D. This is what the script behavior gets out of the box. So anything that node 2D can do, we can do in our code, which is great. And we've got 2 functions that already are added. Let's click this button and expand it, make it bigger. Because when I'm coding, it's nice to just have some space and be able to focus on the code. And we see 2 functions that start with underscores. Functions are bits of code that you can call over and over again to have it run multiple times. And Godot looks for a ready function that's prefixed with an underscore and a process function that's prefixed with an underscore. Ready is called once when the node enters the scene tree for the first time, right? That's a helpful comment. And pass just says, don't do anything. Process is called every frame. So your game's running in a loop. It's running over and over and over again. And it calls this function every single time. And it passes in the elapsed time since the previous frame, which can be used to make movement and other things frame rate independent, which don't worry about that if you don't know what that means. It's okay. We're going to write our first bit of code here. We're going to delete this line. And with the scripting language that Godot comes with is called GD script. And it's its own programming language. It's a lot like Python. And we're going to type some commands into the ready function to make it do some things. So we're going to type print and not have typos. And then in quotations, and these are straight quotes, not curly quotes. When you're programming, quotations are straight quotes. And that is where we can insert a message that will get output. So we'll just say main menu ready. Save that. Click the play icon to run our game again. And you'll see down here, main menu ready was output to the console log. If we changed it, run it again, it changes the message that's output. Okay, let's just double click and copy that. We'll paste it down here and we'll say processing. And we saved it. It automatically picked up our script change. We didn't have to rerun it. We had to rerun it before because ready's only called once. But process is run every function. So now we see its output over 1,000 times. Really noisy because our game's running in this fast loop, right? Like 90, 100 times per second. Let's get rid of that. Delete it, get rid of the quotes, and then just pass in delta. Because delta is a variable value, we don't have to put it in quotes. And it's actually a floating point number, aka a float. And it's usually 0.01-ish. And that's really noisy, not very helpful. So we'll just make that pass again. Now that's some very basic scripting. We're going to get into more advanced scripting soon enough. But we've got our game. We have our start button. It doesn't do anything. But Golly, our main menu is sure ready. Let's go back to Start button, and let's go back to the 2D view, and click Start button. And you'll see we're back to signals. Click Pressed again, click Connect, and we're greeted with a nicer pop-up this time. It lets us connect it, and you can select a node that has a script that you want to connect it to. We're going to connect the pressed signal to main menu, which is our root node, and we're going to call this function on Start button pressed whenever the pressed signal occurs. So you just click Connect. It automatically creates a function for us and says pass. Okay, well, let's get rid of pass and make it do something. We can print and we'll say Start button pressed. Okay. Great. Every time we click the Start button, whether we click on it, we can actually press the space bar when it's focused, and it outputs it every single time. That's pretty useful. Let's get into adding our second scene, which we'll call level 1, and we'll make it so that when the Start button is pressed, we switch to our scene, our first level in our game. So that was just a quick intro, quick recap to we added a scene, a Node 2D scene. We added a label to display some text. We added a button that we wired up with a signal. All of this, while it seems boring, is a really great intro into the concepts we're going to add in our game. So our next step is to add a new scene. You can click this plus button here, add new scene. We're going to make it a 2D scene, and let's go and rename it level 1 and click save. It automatically names it nicely, so we just save it, and now we've got level 1 and we've got our main menu. Let's show you how to run a scene independently from the whole game. So like before, we're pressing the play button and our Start button logs there. Great. Now we have level 1. We can click this button here, which on my Mac it's Command R, but the shortcut's different on Windows and Linux. You can just play the scene that's currently active in the viewport editor. So now we don't see main menu, we see level 1. And we can add a label just for our purposes, and we'll call it level 1, and we'll just keep that in the upper left corner. I might drag it down just a little bit. Now we see we're in level 1. You can close that, right, and just click that. And this is a really great way to test a level that you're building or test a scene that you're working on without having to boot up the whole game, go through the same flow, and get there. This will become more apparent as we work on multiple levels, but for now, just know that this is how we're going to launch level 1. This is how we launch the whole game. And then if we were to focus back to main menu here and click Run Current Scene, it runs the main menu because it's our current scene. All right, so now we have multiple scenes. Let's go ahead and make it so our Start button in the code, you can click this and it brings you to the attached script. Instead of printing Start button pressed, let's make it switch to level 1. All right, so we'll delete that and we call something called getTree. Remember how I was saying a scene is a tree? Well, we want to get the tree. We want to say change scene to file, and as you start typing with GDScript, it will help autocomplete. We see change scene to file, change scene to packed. Well, let's click change scene to file. You just press enter, you don't click it, sorry, I misspoke. And it automatically starts to autocomplete our available scenes. And we'll change it to level 1. Go ahead and save that. All right. Run our game. And click start. We're in level 1. Pretty cool, right? This, again, I know this isn't the game yet, but this is like, you gotta learn to crawl before you can walk. And this stuff is going to be foundational, and we'll see at the end of the game how we're gonna tie this scene switching in and make it work with doors in our gameplay. But we're so close to gameplay. But before gameplay, let's make it so we can go back to our main menu. So in here, we've got our level 1 scene, and it doesn't do a whole lot yet, right? Let's, instead of adding a button to go back to the main menu, let's make it so that if you press the escape key, it springs you back to the main menu. This is quite nice, whether you're pausing the game or, for whatever purpose, but for now, we'll just make it go back to main menu with the escape key. And this gets into input maps and listening to player input. What you do is you go to project settings. This opens up a whole interface of things. What we want to do is go to input map. This is where we'll configure mapping player input to behaviors in our game. There's nothing here. You see show built-in actions. You can click this and view what Godot has baked in, but it's not recommended to use what Godot has baked in. Instead, we'll define our own. So toggle that off and don't worry about it. You can filter with these, but again, don't worry about that. Focus in on add new action. And we're going to call an action called return to main menu. Click add. I keep them snake case named, just like a lot of things in Godot and GD script. And you'll see it's created, and you'll see a dead zone. Don't worry about dead zone. That's for things like triggers and analog sticks, where you don't want the action to trigger unless it passes a certain threshold. So just leave it as is. Click this plus button. It brings up a new interface where it says listening to input. So I just press the J key. It goes, oh, okay, you want to map the J key, and it finds it automatically. But I want to make it the escape key, so I press the escape key. And you can even scroll through here and see all the options. So if you, for some reason, don't have the device you want, like we can make it start button, right? For a gamepad, you can type it in and filter there. But we're going to keep it escape. And then you can add modifiers, which we're not going to do, right? We're just going to say escape does it. And you click OK. Also, you can see the Godot UI is kind of bugging out. Ignore that. Hopefully that's fixed in the future. Okay, so we made it escape. Well, hey, I really like using a controller. I think it's really important from the get-go to support controllers and keyboard. And Godot makes that so easy. So let's go back to filter input and type in start. You can then go and select joypad buttons, and Nintendo calls it plus, but everyone else calls it start, and just click OK. So now, whenever escape is pressed or the start button's pressed, if we check for input from our user, it will come up as return to main menu for this input map. So great, we can click close. Now in level 1, let's attach a new script. We'll call it level1.gd, create it. Let's, just for funsies, let's just add a print level 1 loaded, or level 1 ready. Great. Click that, run it. Click start. We see level 1's ready. Great. Just verify our script's working. You can delete that if you want, but I'll keep it for now. And delete the process function. We're not going to use that right now. What we're instead going to do is we're going to type func. You can type _ input, and it starts to autocomplete. And see that input event? That's what we want. That is a callback that Godot will call. We'll call this function in the code rewrite whenever an event occurs. And an event can be anything like moving your mouse or pressing a controller button or a keyboard button. And as always, we can just print it and see what it is, just to see what happens. This printing is an illustrative way to just see what's going on. So you see every time I move my mouse, you see down there in my screen, it says input event key spacebar, pressed and then released, and Godot's tracking all this input. And you can listen to it if you want. But we don't want to listen to any of it, right? We want to see if it was the action we just described. So we'll say event dot is action pressed, and then in quotes, we put our action. And you see the UI underscore, those are the ones Godot has built in, but we see return to main menu. You can just press enter, it automatically wraps it in quotes. And then we can print that. That will say whenever the escape key is pressed, or click start, so whenever an action occurs, if it's the action that we're tracking, it outputs true or false. Was it pressed? Well, I just pressed the escape key and it says true, and then it was released and then it's false. And when I was moving my mouse, it was tracking it too. So what we want to do is add a condition. Conditioning codes are saying when something is true, then we'll execute this code. So we'll say if event is action pressed, then you put a colon at the end of this condition, press enter, and it automatically indents. Then we'll say print return to main menu action pressed. Now if we go back to our game, or we'll just go and run our scene. Sometimes I quit the game when I don't have to, and that's just like a bad habit. But I just press the escape button, and you'll see down there it's being output. I've got a PS4 controller here. See, PS4 controller. If I press the start button, it also outputs it down there. Great. Okay, well, let's reuse some code we already wrote. We'll go back to main menu. We'll copy this here, bring it back to our level 1 script. Let's get rid of that print and just paste in our code there. But instead of saying level 1, we'll just say main menu. Save that. Now if we press escape key, we're back in our main menu. This switching scenes, while we switched from main menu to level 1, and that is sort of, not super fun, you could imagine though that when an event occurs in our game that, we want to switch to level 2. So now we can at least get back to our main menu, we can start our game and switch between them. Great. Okay, now it's time to actually make level 1. We don't have any image assets, we don't really have much going for us right now. So let's go ahead and find some assets. I'm going to go to my web browser, and I'm at kenny.nl. Kenny is a creator of public domain game assets, and they make games and tools too. So click into assets, and you'll find all sorts of things, from platformers to 3D models. What we're going to do is search for 1-bit. And there is a 1-bit platformer pack. We're going to go ahead and use this to make our game. Because it's public domain, using the Creative Commons 0 license, we can use it in our game. We could even charge commercially for our game. You don't even have to give assets. You don't even have to give credit to Kenny, but I think it's really important to give credit, even if something's in the public domain. So we'll make sure we properly give Kenny credit too. So let's download. Donate if you can. Download the file and then open it and unzip it. You'll see in here a bunch of files. In particular, you'll see this sample, which is kind of like a 2D platformer level. We'll make something along those lines. You'll see a preview of the images, and you'll see some folders. Tiles, which are individual tiles that make up what's known as a tile map. A tile map is a collection of sprites in one image. So it's more efficient for the operating system and computers to take it, load it into memory, and then slice out segments of it. And so imagine, all these little rectangles in here. We'll just cut them out and display them and duplicate them in our game, and we'll make our character move. And just like old flipbook animations, we'll change the animation based upon what's happening. So in the tile map folder, you'll see 4 different options. The one we want, you see packed. Packed means there's no spacing between each of these. But you'll see the one that's not packed. There's this 1 pixel between each tile. We want the one that has 1 pixel between each tile. But we want, let's use the one with the, just use transparent actually. I think that will treat us better. So you want the one that's not packed, that has the gap between them, and click that, drag it, go to Godot, make sure you're not expanded, and drag it into the res area, your file system. So Godot just imported it, and we can see it here. We could take this and just drag it into our level 1 and have this texture here. And you'll see in our scene, we've got a texture 2D with this here. And if we run our game, I should have just clicked run scene. You'll see this image is displayed. And yeah, we can make it bigger and warp it and do all kinds of things to it. But that's not particularly interesting. Aside from we know that it's in our game. So let's go and delete this. Okay. Now what we want to do is set up our level. And we'll do that by adding a new node for our tile map. So go in here, click add node. We'll just type in tile map to easily find it. Click create. Now this brings up a whole brand new interface, which is why we didn't start here, because this is where things start to get a little bit more complicated. Over here, you'll see tile map, you'll see tile set, and then this opened up down here, which is our tile map editor. So we want to create a new tile set from that image we created. So click this drop down and click new tile set. Then click this area and you'll see here that we've got properties for our tile set. Then what we can do is in here, we're going to go and add our image to the tile set. So you need to click the tile set down here. It says no tile set source created. Click the plus button. We're going to do an atlas. An atlas will represent the texture that we'll use from our game. So click into here and click quick load. And that shows the options. We have icon SVG, which comes with the game out of the box. And we have monochrome tile map transparent. Click open. The atlas's texture was modified. Would you like to automatically create tiles in the atlas? Click yes. And then Godot tries to automatically map them. Let's click this button to make it bigger, and you can see that things are a bit off. These orange lines don't line up with our map because we have gaps. So we're going to name this, we're just going to call this tile map, kind of a generic name. And then separation, we're going to make it 1 and 1. And now you'll see that everything is lined just nice. And it's a 16 pixel by 16 pixel grid. If we change this, you'll see it'll throw it off. So depending if you were using a different tile set, you would see how large is each tile set and set it accordingly. There's also an option for texture padding, which tries to help it, but since we have the spacing, we'll just leave it checked on, but that's an option that's there that you might want to mess with if you use a different tile set. A different tile map image. Okay, you might notice some of these are hidden. If you just click them when we're in the tile set editor, it'll re-enable them. For some reason, Godot detected them as, I guess, being disabled. So click those and just drag over it. Ideally, that shouldn't have happened. It does it for empty ones, but it appeared to do it for some that have sprites in it. So if you saw those faded out, just drag over them in the tile set editor, and that should make it better. So now we see here, they're all available, and you can just click the arrow button and select a tile. Like let's select this one, and then draw a pencil, and we can just drag it. Let me zoom in a bit, and we're just drawing it, and that looks pretty good. Now you may have noticed that's a little blurry. So let's try to fix that and make it not blurry. So what's happening is that our tile map texture is like, it's scaling, but we don't want it to scale because it's pixel art. So what we want to do is in the texture, in the filter, it's using inherent, which we don't want. We want it to be nearest. So that says, instead of trying to do some fancy scaling, just do nearest. And we're setting that texture for a tile map. So that changes it just for this imported texture. But let's change it for every texture we import in the future, because we might, add more images in the future. So in the general project settings, if you type in texture and click this default texture filter, see how it's linear? We want it to be nearest because we're making a pixel art game. So click close, and now if we were to go and if we make this inherent, it's already setting it properly. And something else we can do is in the import, we can even go ahead and just re-import that just to make sure that it's proper. But everything seems to be good. Now if we run our scene, we'll see our level is being drawn. Kind of neat, right? Okay, so we've got our tile map. Let's click that again. You have to focus that node to draw on it. And let's just draw a couple more things. So we'll draw an edge here. We'll draw this edge here. We'll zoom out a bit. Draw this a bit. Yeah, we'll draw some walls. Okay. Nothing too exciting yet, but we've got some things drawing to the screen. And we'll start expanding level 1, and we'll add some collision so that when we add a player, that they hit this and they don't fall forever. And then we'll expand what's possible, and then we'll add a level 2. Let's go ahead and add a player that we can control so that we can add them to the world and interact. We'll start off by adding a new node to our level 1 scene, and we'll call it Character Body 2D. Click Create. This is a node that has physics and gravity affects it. It's what will be used for our player, and if you had multiple players, it could be used for that, or yeah, that's what it's for. You'll see here there's a triangle warning sign. It says it has no shape, so it can't collide or interact with other objects. Please consider adding a collision shape. We'll do that in a second. Right-click on it, add a child node. We're going to call it Animated Sprite 2D, because we're going to make it so that our character can animate. And click Create. You'll see a warning here. A sprite frames resource must be specified. So over here in animation, click Sprite Frames and New Sprite Frames. Click that, and now you'll see down here, it opens up a Sprite Frames editor for editing our sprites. What we want to do is click Add Animation. We'll just call it Idle. We'll delete default. I guess we could have just used default. And now what we want to do is add a frame. We're going to click Add Frames from Sprite Sheet because we have our monochrome tile map transparent file from earlier with our sprite sheet. And Godot automatically tries to detect and find things. So we're going to actually change that. We're going to say the size is 16 by 16 pixels. We're going to say the separation is 1 pixel by 1 pixel, just like we did when we set up the tile map. Now you'll see everything is quite nice. Then what we can do is we can click and drag the tiles that we want, the frames we want, to add to this animation from the tile sheet. I'm actually going to unselect them because I was just kind of dragging around all the character ones. But let's zoom in a bit so I can show you some more. So you'll see here our character sprite sheet. And it's blurry because we have to re-import it. Let's fix that really quick. Sorry. Go into here. Let's click re-import. Let's see if that's a little bit nicer. Yeah, there we go. Because remember we changed the project setting? That was an important step in doing that. So by going there to import and clicking re-import, we can now see these quite a bit nicer. And look, Godot even remembered the sizing and the separation. So see this little buddy here with the horns? This buddy is going to be our character. And we'll just set idle to this first frame. And then these will be running. And then these will be jump. I think these will be run, these will be jump. This will be like success, that'll be dead. So we'll just click add one frame. It's a little blurry there, but don't worry about it. Now we've got our first animation, and we'll add more animations soon enough. Let's go ahead and zoom in a bit here. So there's our player. Let's add, right-click, add child node. And we're going to do collision shape 2D. This is what Godot's physics engine will use to determine whether or not the object is hitting a floor or another object and react accordingly. You'll see when we added it, a shape must be specified. You'll see here in the inspector, there's a shape option. So you can click down here and see a bunch of options. Generally for a player, you do a rectangle or a capsule. A capsule is nice because it's got these rounded edges and just makes kind of hitting edges and sliding a little bit smoother. Then you grab these little control knobs over here and adjust it accordingly. Shift it down. But you know what? This sprite is kind of shifted down. So I'm going to click that node for the sprite, shift it up, and then click back on our collision node and go ahead and adjust that. We can make it a little bit smaller. That'll add a little polish. Like, you don't want it to be the whole thing. You want it to be just, squeezed in a little. It's a little more friendly for your player and will feel nice when they're up against walls. So we've got a player here. And if we click this, let's just run our scene first. You'll see our player is just over here up in the upper left. We can't really see them. So let's go ahead and click this, and when I click and drag, it just grabs what's under it. But if you click the node and hold the Alt key and drag, it'll actually drag the node and its children together, and that really helps. So, oops, I started the wrong run. So we see our platformer over here, our little character, that's really tiny. And our game isn't set to scale. We'll set that properly. But our little buddy, let's make them fall with gravity. So if you attach script to character body 2D, it has a template that it's going to add automatically. Well, first, before I get ahead of myself, let's rename that node to player. That will make our script be more friendly named. I'm going to name it lowercase p player. I always name my script lowercase and snake case. But I don't think that really matters. I just do it for consistency. And click create. Now in the script editor, you'll see that Godot has a template for quite a few things already. It sets the speed to a constant value. It sets a jump velocity to a constant value. It gets the gravity from project settings. Let me just show you that. It's in physics 2D default. So you could increase gravity here, but I think 2D works pretty well. You can adjust it as needed. And then there's already some code here that handles quite a few things. So it says, if we're not on the floor, add gravity to our Y velocity. So that makes them fall, our character fall. Handle jump. If UI accept is pressed and not on floor, then we set the velocity Y to jump velocity, which is negative, which makes the player go up. And then here we're constantly adding a positive value that makes them fall. And then Godot handles some left and right movement. So this is actually good enough to start with, and we'll refine it and make it better. But let's go ahead and see what happens. Did you see that? Our little buddy fell and is just falling through the world and falling down because we've got our script attached now, but there's nothing for them to fall and stop them from just continually falling. So let's go back to the 2D view. We've still got our character selected. I'm holding Alt, pressing and moving it. And let's move them above the tile map that we just drew, because we want them to stop falling when they hit the ground. And did you notice that? They just kept falling. And that's because our tile map in our world doesn't have collision set up. So let's go ahead. We'll leave player right there where they are. Clicking the tile map again. And in the tile set, you click it to expand it. And you'll see there's a thing called physics layers. By default, there's none. We're going to add a collision. We're going to add a physics layer. And it has two things, a collision layer and a mask. Collision layer is, there's numbered values. You can change them to strings to make them easier to remember. But collision layer is what layer it's on. And you might want different layers because maybe, let me explain that a little differently. Like, let's say you have a player and they fire bullets. And player bullets can only hit enemies. If they, you know, overlap with something else, they don't do anything, well, then you would put the bullets on layer 2, for example, and you would have them look toward maybe layer 3 with the collision mask so that it only targets certain objects on that layer when colliding. It's kind of a weird concept. We'll get into it a little more. But for now, the default 1 and 1 is totally fine. And actually, I'll explain it more with an example after we set it up more. But for now, just leave it 1 and 1 selected, and that's fine. Now in our tile set here, we need to edit it to define the collision properly. So click in. We selected the tiles that we're drawing with are these right here. So you can click them, select them, and so I dragged and selected them down here. And I'm actually going to drag and select this whole square because we're using the walls too. I'm going to click here into physics layer 0, and you've got these options here. You can add collision based upon the tile shape, or you can draw your own, like whether it's angle or just part of it. And we're going to click reset to default shape. So now, if I click this tile, there's no physics shape defined. If I click here, which was part of that selection that I just made, you see how these are red? That means they have collision associated with them. So let's go ahead and run our scene again after saving. And now you'll see our player just fell and they stop. And that means they're colliding, and we can actually use left and right to make them move. We can use the space bar to jump. So look at that, just right out of the box, Godot, we've got a tile map with a player, and our player can move. Now let's take a quick moment to illustrate collision layer and collision mask. So our player here, if we click collision, you'll see that they're on layer 1, and their mask is on layer 1. Let's put them on layer 2 and click off layer 1 and run our scene. Now the player no longer collides with the level because our tile map collision is only on 1. It lives on 1 and it looks towards 1. If we set the collision mask to 2, it looks to collide with objects on mask 2, on layer 2, or sorry, yeah, on 2, but it lives on layer 1. If we make our player live on 2 and look toward 1, now they'll collide because the layer and the mask are aligned. Again, don't worry about this too much if you don't understand it. It's a more intermediate topic and something that I'm not sure if this tutorial will cover more, but you can get pretty far with just leaving it all on 1-1. And as your needs for your game grow, the needs for that will grow. Now, so in the tile set editor, there might be other objects we want the player to collide with. So I'm just going to go ahead and select those as a group and reset to default tile shape. You could even see that the F key does that quickly. Like all of these, we just, even if, you know, I think we're going to use them, so we'll add them. These blocks here, they seem like they're things we would collide with. Doors, maybe not. Door we would just overlap with. So we don't necessarily want to have that be on the collision layer. And let's see, anything else? All of these seem like it. These all seem like it. And by having a tile map like this and not having them all have collision, you can add decorative tiles that the player doesn't run into. Like, for example, if I go ahead and there's also, just real quick aside, there's a thing called one-way tile. If you were to select it, like, let's go ahead and make this triangle platform. I select them all. Click one way. And yeah, I'll show you this neat feature because maybe your game wants that. So I had selected these triangles. I'm going to select those and I'm going to draw that right there. And I'm going to draw that right there. let's go ahead and run the scene, and I'll show you what the one-way does really quick. So I can now jump through the tile, but then when I'm on the top side of it, I fall and collide with it. Now, if we went back into our tile set, those are still selected, which is cool. If you toggle one way off and save it, might have to rerun it because of that changing that setting. Now I hit it and fall, and I don't go through the platform. So that just depends on your game's needs and like a given tile's needs. But I'm gonna actually turn that back on because I think that's pretty useful for that tile type. And that also shows that, you know, Godot is updating things in your running game. But sometimes if you change certain things, you need to rerun it for that to stick. Okay, great. Let's go ahead and paint a little bit more. Let's add a decorative pipe up here just for fun. We'll just kind of put this here, put that here, you know, that kind of thing. Godot has some advanced tools for making tile layouts smarter and easier. For this tutorial, we're going to just focus on making, you know, handcrafted levels that we place everything manually. So now we've got some decorative items in our scene. Sorry, I alt-tabbed to the previous recording. And now you see I don't collide with the tree, I don't collide with the pipe, but I do collide with our platforms. There's a couple things I'm noticing that I'd like to change. So let's just go through them one by one. Player script. I'm going to go ahead and close this. A couple things I'm noticing. Well, first, let's start by, we have action just press. It's using UI accept and UI left and right. Let's make our own input actions. The comments here even encourage that. So remember what we did? We'll just do move left, and I'm going to enter these pretty quick. Move right, and then jump. So you can add those quickly, and then you click the plus button, and I'm going to make it custom controls. So left, I like the A key, like WASD. I also like the left arrow key, and I also like the left stick to work, and I like the left D-pad to work. So that gets us all the input I like. And just out of the box, by default, I like to support 3 control schemes. Controller, WASD, and then JK for confirm, and then arrow keys and ZX. I think by giving players options, whether they have different keyboard layouts or different needs based on their hands or how they like to play, I prefer to do that. So let's go ahead and we'll do D-pad right. We'll do left stick to the right. Not the right stick. That could be a little confusing. We'll do move right. I'm going to listen for input and use D to move right. And I'm also going to use the right arrow key. So we've defined those. And then for jump, we'll define a few things. Space bar, that's just like pretty common. We'll do Z, like I said. We'll do J. We'll do the A button on the controller, which if you scroll down, that is defined as bottom action, Sony cross or X, Xbox A, and Nintendo B. So that gives us the basics there. We can close that. Now delete UI accept and change it to jump. And then delete UI left and change that to move left and move right. And we'll do a little bit more investigating, and I'll explain this code a bit more. But let's, one piece at a time. Go ahead and run the game. I should have just run the scene, sorry. And then just verify it works. Okay, I jump with the space bar. I jump with J. WASD works. Z works. Test it with a controller if you have one. That's feeling pretty good. Okay, great. Another thing I want to experiment with is changing the speed. So let's get the game running and leave it instead of quitting. And we'll change speed to 200 and save it. Now move your player. You see it's a little small, a little slower, and it's so zoomed out. We're going to fix that, don't worry. So the player moves a little slower. let's change jump velocity to negative 200. Player jumps less high, right? Because they have less velocity being applied when they jump. So change it to 300 and just make it feel good based on your intuition. A lot of this sort of game design and game feel is based on intuition. So I'm going to change speed to 250 and I'm going to change jump velocity to 400. And that feels pretty good. And experiment with those values. The next thing I want to show is gravity. The way it gets it, we showed where that's coming from. This is how you get that value. That's pretty nice. When you put settings there versus when you do and don't, really depends. Really depends on what your project needs are. If you have something that's shared across a bunch of nodes, you could put it in there and change it. There are many ways to go about that, but don't worry about that for now. Physics process, this is like process where it runs every frame, like in our game loop, but physics process might run even faster because it's simulating the physics. So, the game is calling this function a whole bunch. If we put a print, it would happen all the time. Delta is the time between the last time it was called, and that helps make the game frame rate independent. So like the amount of gravity that's applied when falling depends on how fast. It doesn't depend on whether or not the game is running slower. So because imagine you're on an older computer, it's running slower, and there's 0.5 seconds instead of 0.1 second between things. That's applied to this gravity calculation, so the amount added to the y velocity would be bigger. Delta time is a foundational part of game programming, and there are times where you apply it, times when you don't. Sometimes Godot automatically applies it in certain places, so it's a bit more complicated, but just know multiplying things by delta helps make things frame rate independent, and we'll get more into that as needed, but it might not even be something we cover too much in this video because Godot kind of gave us out of the box what we needed. And then we check if it's jump, and we're not on the floor, right? It's nice how readable the code is in GDScript. We set the jump velocity to y. And then input get access. You may remember that we, in level 1, said is action pressed, and that is pretty similar to this. Just pressed means that it's not being held, because jump is, just happens once. But get access says, what is the difference between these two input values, and get them as a vector, and or get the value and output it. I don't know if it's a vector. Let's print debug and see. So it's 0. I just pressed left, and you see the values oscillating between -1, 1 when I'm moving right, -1 when left, and 0 when not being pressed. So yeah, it gets us a numerical value that says which direction are we moving in, and then we multiply it times speed to go left or right. Otherwise, if there's not movement, then we move toward 0 at the speed of the player. So this slows the player down, and it applies the speed towards that. And if we for example did it at the speed half the speed, this would add a little bit of slowdown, a little bit of drag to our player, just ever so noticeable. And actually, let's remove our print debug here. That's causing some noise. Divide this by 10. See how that, after you stop pressing, the player moves a little bit. You could even multiply it by delta if you wanted, just to see what happens. It's a really small value. And after I let go, my player keeps moving. It's, kind of mess around with that. But you might want to do it divided by 2, and it just makes the game feel just a little bit better when you let go of, a direction you're pressing. So, okay. That's that. Move and slide is a function that exists for certain nodes in Godot that says take the velocity, apply it, move this object, and check for collisions. And if it does collide with something, slide or stop motion based upon that. And let's learn about reading Godot's docs, because that's really important. So in Godot, you can search help You can search for anything in here that's a function that exists or a class. So if I type in move and slide, it filters down to character body 2D. You can click open, and you can read what this does. Moves the body based on velocity, which is what the code Godot gives us as modifying. If it collides, it will slide rather than stop immediately. And you reading this is so important to understanding what Godot's doing. So let's click back into player. You can actually press Command on Mac and Control on Windows and Linux and click, and automatically just right there it opens it, and you can read the documentation. I can't recommend that highly enough. If you already know how to code, you'll be reading the docs because it's how you'll pick things up. But if you're new to coding, that's a really good habit to get into, is instead of just right away Googling something, read the documentation. It's going to be up to date, accurate. Godot's docs are quite good. Really recommend it. So again, this is code that Godot gave us. It's doing a lot out of the box, which is really helpful, and it's good to understand it. So I would recommend experimenting with it, maybe try changing it around or inspecting the values. But I think for now, it's good enough for our 2D platformer. So what is the next issue that we're being faced with? It's really small. Like, really small, right? Someone wouldn't want to play a game. If we made a whole level, like I'll just quickly paint an entire level of things, right? So we'll just, in here, I have to select the tile map, and in here, select the tiles we want to draw. I'll just draw like an overlapping platform, replace the middle parts with the middle parts, and make it go down. And by placing this tile here, it makes it look like this is in front of it and adds some kind of faux depth to the level, which is cool. And then we'll make it so that the player has to jump, and then we'll go ahead and I think we added some stuff here, so we'll just kind of make this block type thing happen, and we'll connect them and make it a big old block. And okay, great. Let's run our game again. I think I might have quit it. I can't remember. And oh, okay. We might be missing collision on some of these. So let's go into tile set. It's this chunky line. So here, oh yeah, you can see where there's collision and where there's not. So let's define some more collision. Something also that happens is when our player falls off the map and they die, we are left having to restart it from here. We're gonna make a shortcut to make that easier. But for now, let's go ahead and, okay, we got collision working. And now I can run off the screen here. See the characters leaving the screen. Let's add a camera that zooms in and follows the player. And Godot makes it pretty easy to do. So what you want to do is add a camera. So add a new node and add camera 2D. And we can do a couple things right here. We can drag this into our player node, and it will follow the player. And we can set the zoom to be 2. So we see here that the camera is here, but our player is kind of over here. So we can move the camera by pressing Alt and center it on the player. And that feels pretty like an easy solution. We'll see how it works. Great, now we're following the player, and we zoomed in twice. Everything's bigger and a lot more visible. That's feeling good. Let's change the zoom to 3. That's feeling pretty good. I like 3. Then we fall to infinity, and that's an issue that we'll fix. But let's look at a couple other things. So you can add limits to your world, so your camera hits an edge, and then the player would move, but the camera wouldn't. But we're not so worried about that. Smooth would make that smooth when it happens. But we can do something, enable position smoothing. This makes it move toward the player at a little bit of a speed that feels pretty good. And we can even add some drag. That'll just really make the camera just pretty quickly feel a bit better. So you might notice the player is really jittery with this. I don't know if that's coming through on the video. So we'll turn those off and run it again. Yeah, so jittery. Is it the position smoothing? Yeah, the position smoothing is weird. Haven't run into that before. But if you turn on the drag, you'll see that the player starts moving before the camera does. That feels pretty good. The position smoothing is weird. I don't know why that was happening. Maybe we could adjust the value a little bit to maybe be 10 pixels a second. You know, I'm still learning too when doing all this stuff, so sometimes it's a little bit, I'm figuring it out too. I don't know. Let's just keep that off, and maybe that's something to learn more about. But I think this camera's working good enough for now. And yeah, so we're zoomed in. We've got a player. They're moving around. Things that we need to do next are animate, make it easier to have the scene reset, make it easy to go to another scene, maybe when we reach a door. Would love to add gem collection, kind of like coins in Mario. Yeah, but we're really making progress, and you could go and click into your tile map and, design your worlds and your levels, and add collision where needed, and, add decoration to your world, and, just kind of make it fun and jumping. Oh yeah, we'll also make the player jumping and movement feel better, because right now I would say it does not feel so good. Let's, as our next part, to introduce a new concept, I would love to make it so that we have a level 2 that has a tile map that's different, and then we can change between the levels, because that will introduce some new needs in our game that are pretty important. So let's go, and we'll just add a new scene, and we'll do a node 2D, and we'll call it level 2. We'll save it as level_2, click save, and if we run this scene, we're basically back to where we were, which is nothing. You can click in the level 1, and you can actually copy this stuff, which is cool. So I just pressed Command-C or Control-C if you're on Windows or Linux. You can just, don't select level 1 though. Select its children. And then you can just select it and paste it. And we're in level 2 now. We run this. We've got everything there, and everything's working. And that's pretty cool. And because it duplicated the tile map, and we have our tile set with our tile map already defined with our collisions and such, we've got everything configured. We can go into the tile map here, and we can select the eraser. We can just erase the level and design level 2. There's got to be a faster way to do this. Let's see. Rectangle select. There we go. So if you select the eraser and rectangle select, that'll erase it. Then you can go ahead and click, and we'll make this level like pencil tool that, unclick the eraser, place random tile. That's kind of fun. I don't know how that works quite yet, but we'll just add this, and it'll just be this sort of trash level for now. But now let's go ahead and run level 2. Our player falls, and we've just got our kind of bad level. You may have noticed that level 2, that label we had in the upper left, isn't showing anymore. Because in our world, you can't see it, but like way up in the upper left is where that label lives. So we've got a couple things to fix and change right now. Okay, so we want to get this label to display in our camera, not in the world, right? Like if we drag this here, Now you'll see that level 2 will show up in our world right there. And that's not what we want. We want it to display in the upper left of our camera viewport. So we can do that, add a new node. We'll type in canvas layer. That lets us draw, it draws its children to the camera based on its position in our layout here. So now if we go ahead and run the scene again, just by making that level 2 label a child of canvas layer, it's displaying up there and it sticks with where our camera is. This is really helpful for the heads up display. And you'll notice that we did this in level 2, but we didn't do it in level 1. So let's quickly go back and do it. It's good practice. You just drag it in, make it a child, run it again, and we make sure it works. So that's one issue that I wanted to fix. The next issue is that this player, while it shares the same script, player.gd, this player in level 1 is fundamentally disconnected from layer 2. Like if we go ahead and change our sprite, our animated sprite here, to use a different sprite, like click into here, select this, Godot does not remember it, right? It's 16 by 16 with the 1 separation. If we made this player instead be this little horned friend, an add frame. Oh, it doesn't like something there. 16 by 16, 1 pixel separation. Something seemed off there, but there was like a part of the foot selected. Let's try that again. Yeah, that's better. So delete the other frames, and then go ahead and run level 2. So level 2 now, we'll see the player is this little skull with horns. Then if we run level 1, oops, that's level 2. Let me refocus level 1, end the running scene. This player is now just our normal little buddy. That might be a neat feature if you wanted it to, but it'd be better to change that with code. And the properties of the player are just now fundamentally different. Like the collision layer, the maps, the mask and the layer, they're disconnected. So what we want to do is make it so that we can share the player across our different levels and our different scenes. And all we need to do is here, we'll delete this node for the player, save it, and then here in our player, right click and say, save branch as scene. And it automatically wants us to save it as player. So I went ahead and did that, and you'll notice its children are gone. And now there's a movie clapper, a film clapper, which is open in the editor, and we still have the script associated. So now if we click open in editor, and if you go to the 2D viewport, here's our player. I have to zoom in so we can see them because of how tiny it is. But now you'll see our players here. And what we want to do actually is take all this, select everything, hold Alt, drag it back to the center here, and grab this little cross. Oop. Actually, select everything. I undid that. And just select the... Sometimes this is a little tough of an interface. Okay, select the top node, hold Alt, and drag it. That drags the center cross, the sprite, and the camera to the center viewport. Before, the player was all shifted to the right, but we can just keep the player right here and have them exist nice and in the center. And we'll see that something else is a little shifted. The camera is. So we'll select the camera here, hold Alt, and drag it. Now the camera is centered with the player. It could even be shifted up a little. Now everything's centered. Back in level 1, you'll see player is now centered, but we can actually go and hold Alt and move the player this way easily. So we're just dragging the player around, and we can place them at the start of the level because this is where they'll be when we run the scene. So we created a branch of our scene and saved it as a scene, and then we instantiated a version of it that we can then run. And then now in level 2, all we need to do is click this link or the shortcut, and you can instantiate another scene within your game. So I'm choosing player.tscn. And then you can just drag them to the starting place, run the game, and it's the same player. And we can go in here now into our player scene and manage the player's script. We can manage their sprite. We can go ahead and change things with ease. And that makes such a big difference. And you'll do that with all types of things, all types of objects in the game. And we'll do that a little bit more. But now let's go and we'll change it to the little buddy. It's got the weird side, but that's okay. And we'll just drag it to the left for frame 1. Rerun the scene, and we'll see it's the horned buddy. And now if we were to quit and run level 1 again, it's the horned buddy. So now it's shared, and that's ultimately what we want. So go back, delete the little horned guy, and save our player. And so we've got level 1, level 2, we've got a shared player. Now let's make it so that you can go from level 1 to level 2 when you reach a door. Before we jump into switching levels, let's take a moment to pause and make a to-do list. I'm going to open up a text editor called Sublime Text. And I'm going to start making a to-do list because I'm having trouble keeping track of everything that we want to do. So we'll do to-do, we'll do done. So we want to add doors to switch between level 1 and level 2. We want to, I'm just going to run the game. Make the player animate based on the direction they're moving. And jumping. I want to add some collectibles that are tracked across levels. Collectibles tracked across levels. Export game and upload to itch.io. And I think that's good enough for a basic platformer. You could go and add enemies and things like that, but I think for our case, this basics will work. And as more things come up, we'll add them to the to-do list. We'll add some other little polish, like we'll add setting for full screen. We'll add SFX for jump. Music track. That would be really great. Differs per level. We'll add a setting for full screen that players can toggle. We won't necessarily save it to the disk. That's more advanced. And then we'll add a quit button, but only on desktop. We'll say hide on web. And then let's also make escape go to main menu at any time from any level. And then let's add a level 3 to show how easy that is. And then when we're done, we'll upload it to itch. And what we've already got is main menu, levels with tile maps, player. We've done quite a bit. So let's go ahead and add doors to switch between level 1 and level 2. We'll start on level 1. And what we want to do is in level 1, and you can actually do it as a child of the tile map, or you can just do it above it. I think it is fine either way. We're going to add a new node called Area 2D. And this will be used to detect collision with the door. So it created it here and there's nothing there. And you'll see this warning. Remember in the past, it always shows it when it's incomplete. It wants us to add a collision shape 2D. So go ahead and add a collision shape 2D like we've done in the past. We'll make it a rectangle, and that's pretty good. Okay, so we want to display a sprite for the door. So go ahead and add an animated sprite 2D. We might not animate the door, but this will be a pretty easy way to go and handle this, similar to like we did with our player. So we added a sprite frame, and we'll go ahead and add default. And then here we'll open up our tile map like we did before. We'll set the size to 16, and we'll separate them by 1 pixel. And there might be multiple ways to do this, but I think for our case, we'll just go and do it the way we know it. And here we'll just add a frame, and it added the frame door. Now you can see our doors here. If we click into this collision shape, it's a little bit big. And we're doing this separate from the tile map collision layer because we don't want the player to stop moving when we hit the door. We want to just know when they've hit the door, and then we'll change the level. So now we've got this door, and it's quite a bit more aligned, our collision shape. We can then zoom out a bit. Remember, hold Alt and drag it. And we'll put the door over here on the right to encourage the player to go over there. And now as we're dragging it, you can see it's not really locking to anything. So you can click here, and we can do a couple things. We can toggle smart snapping, and we can show a grid and enable the magnet icon there, says snap to grid. So now it's snapping to the grid and feels quite a bit nicer. Here also, let's rename area 2D to door. And if we wanted to add a door animation, we could, but we haven't gotten into animation yet. So we're not gonna worry about that. But let's go ahead and wire up a signal that deals with our door area 2D. So area 2D has a few different signals: area entered, body exited, area shape entered, body shape entered. We want to do body entered because when the player body enters in this blue rectangle of the collision shape, we're going to want to change levels. So let's connect this signal to our level 1 script, and we'll just print debug and say player entered door. And then run this scene. And then move the player over there. And then, do you see player entered door? Every time we go in, that gets triggered. It's actually getting triggered twice. So that's kind of interesting. I don't know exactly why that is. There's something kind of interesting about that. I don't know. Sometimes it happens once, sometimes it happens twice. I guess it depends on if you overshoot it. But for our case, knowing that they entered is fine. And then what we'll do is, instead of changing to main menu, we'll just go ahead and change the scene to level 1, or level 2, because we're in level 1. And Godot helps us with autocomplete there. And then now if we run just this scene, oh, I ran level 2. So for some reason, it went and changed it automatically. Now, why is that? I think I might have an idea. Let's figure it out. If we do print debug body and just have it output what the body is, we'll learn quite a bit. So it's saying that the body that collided with the door is the tile map. And we don't want that, right? We only want to follow when the player collides with it. So that makes sense why it wasn't working. So we can say if body equals, and then we can actually do $player, and that references our player node. So now if we rerun this, you can see it didn't change the scene right away, but then when we hit the door with the player, it goes and changes to level 2. Let's talk about this more in depth. So body is whatever entity in our 2D worldview is colliding with the door. The tile map level that we added collides with the door. And our player collides with the door. In our script code, we want to check and say if the body that entered the door is the player, then we change the scene, only if it's the player. And we can reference our player node here, which is an instance of our player scene, with the $sign. And that says specifically, is it this player that entered the door? Does that make sense? We only want to change the scene if it's a player that enters the door. If you had an enemy that was walking by and they walked past the door, you wouldn't want to change the scene. So we go and we check and we ensure that the object entering the door is our player. And there are various ways to check this, but I think this is pretty clear and works. You can see if we type $sign, Godot will start to auto-complete the nodes in our scene for us. So like you can get player, and you can even get the player's camera, and you can modify the player's camera. And that lets you easily access things and set properties on it, which is really, really helpful. But for our case, we just want to just ensure that the body is our player. So that's a door. Let's go ahead and add a door to our level 2. And we can let's make our doors reusable just like we did with our player. So we'll go ahead and click this and we'll say, save branch as scene. We'll call it a door. And then we'll open the door scene. We'll open it in 2D view. And it's way over to the right. Remember, we had the same problem with the player. So select it all, drag and select it, and then bring it back to the center and recenter our door. And this just lets us have the origin of the door be right in the center, and it centers it here. Now, back in level 1, it moved it because we moved it. But now we can just select our door and drag it over here, just back to where we had it. That's just one of those little things that when you create nodes in your scene, move them around, and then you convert them to their own scene, you sometimes have to reposition them, and that's fine. Let's go ahead and notice a couple things. When we click into door here, our signal's not connected. And in our level 1, we lost our signal connection. And that's okay. It's because we converted to a scene. So just click connect again, and you can actually pick an existing function in our script because we already coded it. So you can just go in here, click select it, and connect it. And now it should be working right again. So we'll click start, we'll run over, we'll jump to the door. Now we're in level 2. Let's add a door to go back to level 1. And then when we eventually add level 3, that will be nice. And, we could even, just for fun, we could add a label. And that's going to be at 0, 0. So let's zoom out, drag it over. And here we'll just add we'll call it level 2. So we know, our player knows, it's kind of fun. It might be pretty pixelated. Let's just run just the scene. Sometimes the way the text scaling works is a little funny. Yeah, it's a little pixelated, but you know what? I don't think I really mind it. I think it's kind of charming in a certain way. If you had a different font, you could go and make it like a pixel font. That would make it look a lot nicer, but I don't see any options to make it look better. And why this is happening, I think is maybe worth talking about just a little bit, is, we have our camera zooming in, and the font gets zoomed in on and doesn't have any sort of scaling applied to it. So it's just zooming in on the pixels of that drawn text. And that's, yeah, what are you going to do about it? It's totally fine. We can even drag the label as a child of door. And when you make a node a child of something, and you go to the scene, it's no longer a child in the parent scene. It's just there in that instance of it, and that's actually pretty useful. So let's select door, Control or Command C, copy it, go to level 2, paste it, and now we've got a door, and our door is going to be positioned way over here. So grab it, hold Alt, drag it, and we'll just say turn on grid snapping. We'll just drag it here, make it look nice. Okay, and we'll shift it over. We'll make this level 1. And then our player here is going to fall and collide with the door, which isn't ideal. So, and we could make them kind of come out of the door and move, but I think it's actually a little easier to to make them just kind of spawn to the right of it, because if we spawn them in the door, it's going to trigger the body entered, and let's not get into the advanced topic of handling that logic. I think that's something worth doing, but I don't think it's worth doing quite yet. And let's make that a little closer, and we'll move this one down just a little closer. And we'll run this scene, and we'll see what happens. So our player spawns here. We go into the door, and nothing happens. That's because we need to wire up the signal again, right? It's looking like it's connected because we copy and pasted it, but it's not connected quite in the right way. So you disconnect it, and then you can connect it again. And we don't have a level 2 script yet. So let's go ahead and add a script. We'll call it level 2. We have all this stuff here. We can delete it. And then now we go back to the door, body entered, connect. And maybe we should do the door stuff. That would be fun. Let's put it on the to-do list. Switch level to door and track readiness to enter. That'll be a little more advanced scripting, and we'll do that a little bit later on. But let's connect this. And from our level 1 script, we'll just copy all this, paste it, but instead of changing to level 2, we'll go to level 1. Go ahead and rerun level 2, and we'll see what happens. So great, we can jump around. Click that, and it spawns us at the spawn point of level 1, not our door. And that's probably okay, right? Like, maybe if you had a game that was like a Metroidvania type game, you might instead have a way to track like which door a player is entering and going back into. But I guess for our case, for a Mario style game, you would just want to spawn them at the beginning of the level and they would move on. So yeah, that's just a behavior that we've got here. And we'll make it so that we'll delete the to-do for handling level readiness in the door. I think if I made a video that was like how to do a Metroidvania and you had doors and you were entering and exiting them, that'd be its own video, because that stuff gets pretty complex. So, okay. Let's look at the to-do list, right? This is why to-do lists are really helpful. You can go and keep track of how you're going. So great. We've got doors that switch between level 1 and level 2. That's pretty cool. And I like to go and just run the game again, test it, make sure it's feeling right. All right, yep. We can go ahead and play our level. That is good stuff. Then what we can do there is we'll add a level 3 at the end. We'll do that at the end. Now, when you press escape in level 2, we'll start with that, because I think that's a quick thing, and sometimes it's nice to just do quick things. So if we run level 2 and press escape, we don't go to the main menu. If we run level 1 and press escape, we go to the main menu. So all we need to do here is, in the input event, you can just copy and paste it, run it. Now, if you press escape in level 2, it goes ahead and does that. And that was simple, but we've introduced duplication in our code. Some duplication's fine, right? Like this on door body entered and connecting the signal, the level changes based on that. So, it's not the best to duplicate this code because maybe we want the logic to be more complex, but it's not too bad. But this input event where we return the main menu, that is the same exact code in two places. That is usually a sign of an area where we can make the code better. And we'll make this better by introducing one place that this code lives and gets checked against every scene while running. And the way that this works in Godot will also be used for keeping track of things like for collecting gems or how many lives the player has and that sort of thing, right? So let's go ahead and go up to project settings, auto load, and then in here is a whole new interface. And what you want to do here is just type in a node name, and we're just going to call it global for now, and click add, and it brings up this interface for creating a new script. We'll call it global.gd, click create, and by default it's enabled as a global variable. So it is a area of code that we can access as needed, which is quite nice. And it'll always run when our game runs. So we'll click close. Now global's been added to our game. You have to double click it down here and open it in the script. And let's just do some learning to see what happens. We'll do print debug, global ready, save it, and then we'll run our game again. And you see global ready was triggered and then main menu. Now when we loaded level 1, global ready didn't get called again, which is great. That is what we want. Now if we in here add print debug global process, save that, that gets run every single time like our other process. So that's helpful, but we don't really need that. Also print debug is like printing, which we've been doing elsewhere, but it only does it in the debug mode of your game, which is like while you're working on it. But then when you build your game and share it with players, this won't happen. So I think this can be nice to keep in sometimes to help you know when something's ready and being triggered. So print debug's really helpful to help you, the game developer. So what we want to do is in level 1 and level 2, we'll cut this out. So select it and you can press Control or Command X, and then just, go back into global.gd. You can't switch to it from up here because it's not a scene. So just go back, paste it in here, save it, and then in level 1, we've removed it. In level 2, just get rid of that input event. Now run the whole game again. We see down here, global's ready. If we press escape, it switches to main menu, but that doesn't really matter because we're in the main menu, so it's not a big problem. Now if we're in level 1, we press escape, it goes to main menu. And then if we go to level 2 and press escape, it goes back to main menu. And now our code only exists in global.gd. So that's pretty handy. So we'll do more with global.gd eventually. I also just realized something that we want to make better in the game, which is we want to, as part of our polish, we want to make it so that we focus on main menu buttons on launch for controller support. For controller and keyboard support. Because right now, if you launch the game and you press the spacebar or use your controller, nothing happens. But we want to make it so, yeah, you can click the start button, but we also want to make it that you can use your controller and your gamepad for that, and it's really easy to do. So we can just go ahead and do that. But we'll do that later. So we've got a couple things. Animate the player based on movement and direction and jumping. That sounds really good. Let me actually save this to-do file because I keep doing it out of habit. And yeah, now I can save it. So let's animate the player based on movement and direction and jumping. So we'll go back to player and we'll look at our player right here. We'll close this, make it a little bigger. We have animated sprite 2D and we have idle. Let's go and add a new animation and we'll call it run. click here, select this again. I don't know if there's a better way to do this, having to keep selecting it and set the separation and everything. But this is what's been working for me. Still got ways to learn. So we'll click this tile, we'll click that tile, and we'll just make that the run loop. And you can click this play button here and see it run. And you can even change how fast it goes or how slow it goes by changing this value. I think 5 felt pretty normal. And maybe the run loop that I'm showing here, maybe it looks funny. Maybe I picked the wrong frames. Yeah, let's open this again and let's zoom in a second and look at it. Let's make sure I picked the right frames. So, do you think that third frame would look good? I think so. Okay, let's add that one in too. So, again, we'll just go and click into that third frame. And now we've got it. Okay, that looks quite a bit better. And let's see how it looks at 6 FPS. Yeah, that looks pretty good. So now we've got these two animations. And we want to play them based on what's happening. So, go ahead and save that, and then click to open our player script. And we'll drag this down, but keep the animation. We can't. Okay, we'll just drop it down, and we can reference it as needed. So, what we've got here is our script from the player that was added by Godot. I'm going to clear out these comments just so we can have some focus. And here we have direction. And remember, direction was either -1, 0, or 1. And if it's 0, we move towards our velocity. Otherwise, we start running. So then all we have to do is we can say animated sprite 2D, and we reference the node with the $. And you can just say dot. You can say play. And then you say what animation do you want to have played. And we're going to go and say, when moving, we'll do run. Otherwise, we'll play idle. There might be some problems with that code, but we'll go ahead and learn. So that's working, right? And then we stop and the player's idle. Do you notice anything that's wrong? I noticed a couple things. One is that the feet are kind of hidden at the floor of the level, and when we move left and right, the player doesn't move accordingly. So let's go ahead and fix those two things. Let's bring this debugger down, hide the output, and let's do a couple things. We'll say if direction is equal to -1, we'll say animated sprite, -1 represents left. We'll say flip horizontal is true. Because by default, right, our player's facing to the right. But if they're moving to the left, we want to flip it to the left. So we say flip horizontal true. And then we'll say else false. Let's go ahead and see what happens in our running game. And we see, okay, that's working. When we jump, running is still happening, so let's go and add a jump animation. We'll go back here to our animated sprite 2D. We'll click into the animation, into the sprite frames, and we'll add a new animation called jump. Same process as before. And then we'll zoom in this frame, there's one frame here that looks really nice for jumping. We'll just add that frame. And it's just one frame, doesn't animate, doesn't loop or do anything like that. Let's bring these down, expand this. And then what we want to say is, if jump and not on floor, we jump and we add the velocity. Here we have the movement. But what we want to say is at the bottom, after all this code is processed, we'll say if not is on floor, override what was ever set before, you know, because like maybe this is true, it's set to run, and maybe it's flipping horizontally, and that's important. We still want that to be processed based on the direction of the press. But if we're not on the floor, go ahead and do jump. Now if we go back to our game, and we're moving and we jump, that's not working. Maybe we need to rerun the scene because we added a new animation. Oh golly, what happened there? Oh, I ran the player scene. So the player has gravity applied and it's just falling. So let's go back to level 1 and click run scene. And now if I jump, you see jump is happening instead of running. Great. If we're facing left and we jump, it faces in the right direction. And when we stop moving, the player just looks right at us. Maybe you would change the idle animation to instead be facing left or right. That's ultimately up to you and what you want. So now we've got basic animations happening for the player. Another thing I just remembered we want to add is quick level reset. But let's go ahead and just play with that some more. Let's find a long stretch to run. Oh, I went to level 1 really quick, or level 2, and yeah, we can run back and forth. That's feeling pretty good. But like I noticed earlier, the player's feet are kind of hidden in the level. Maybe if you had grass, like decorative grass, that'd be nice. But for our case, it's kind of doesn't seem good. So let's go ahead and change that. And the reason why this is happening, what's the reason why this is happening? Let's go ahead and in our animated sprite 2D, we'll select idle and we'll look at this. We'll look at run, we'll look at jump. Jump is good, right? This collision sphere is below the feet of the player, so that feels pretty good. But here, the player's feet are below the collision sphere. So what you can do is you could grab the collision shape 2D and drag it down, or we could drag the player sprite and just drag it up. So now they're aligned. Do you see how the bottom of this blue oval is aligned with the player's feet? Now if we go back into Godot, we can see the player's feet. And that just looks a little more natural, right? It looks like the player's running, and that's definitely preferred. So yeah, we got the player animating. That wasn't so painful, was it? We'll just recap. You click in the animated sprite 2D. The Godot inspector is really giving me a hard time right now. Let me minimize sprite frames. You click into here, into sprite frames. Then you go down here into the sprite frames area, and you can define your animations. Then in your code, where you have the animated sprite 2D, you can just go and say play certain animation, and that will do the trick. So that's player animation. Not too bad. Now let's do collectibles, and we'll keep track of that data across the level. All right, so in our tile map, I just double-clicked it and opened it. Might be a little hard to see, but there are little gems. There's this coin-looking thing. We'll call it a gem. Let's make it so you can collect the gem. And then we'll get into sound effects. So just like we did with the door, we're going to create a new scene, and we'll say other node, and we'll say area 2D, just like the door. We're going to call this gem, and we're missing a collision shape, and we're going to make it a rectangle for now. We're going to add a child node. We'll do animated sprite 2D again, just because that makes it really easy to add animation if we want it, and to just define the sprite frames. So click that, add new ones. We'll just do default. Click into here, load that. Okay, and then we'll zoom in and we'll pick one. We'll pick that gem, add one frame, and now you can see that we've got this gem. We'll save gem.tscn, and let's just make the collision shape just a little bit. It's got magnetism on, so there we go. Turn that off and just pull it in. I'm going to keep it a rectangle. You could make it a circle or an oval, but I think a rectangle is nice because it's just a little more forgiving to the player. And I've got about a pixel of space on either side. And we've got our gem. Now, what we want to do next is put these gems in our levels. So here's level 1. And all you do is the chain link, click gem, open, and then you'll see at 0, 0, our gem was added. So alt-click and drag it. We'll just add some gems here, like there's that. Let's take our player, we'll move them over here. And then you can, with your gems, you can press Control or Command D to duplicate. And you can add them to your level and kind of encourage the player where you want them to go and lead them places. We'll put one here, one there, put one there, put one down here, one here, and then that's gems displaying in our level. So go ahead and run the level. But then when we hit them with the player, which sometimes can be a little tough, nothing happens. Well, that's because we need to wire up the gems to keep track of themselves and to hide themselves when they're collected. So up here in our scene area, let's go, to gem, and we'll do a couple things. We need to attach a script. Gem.gd is great. We'll go ahead and clear this out, because we don't need any of the default code there. And we'll wire up our gem, the body entered 2D. And we'll hit connect. And we'll say on body entered. We want to do a couple things. We want it to make sure that it's a player, just like before. So we'll make a comment and we'll say 1, make sure player. 2, add to total collected gems. And then we'll say 3, remove from scene. So let's do it in that order. We'll do print debug, body, save it, and we'll run the level, and we'll just jump up and see that. Okay, and we see that it's the player. Now, we don't have a $ player that we can check. So what we can instead do is inspect the properties of the body, which we know is a character body 3D. But we might even be able to do something like if body dot name equals player, because we named it player. That's one way to go about that. Then we'll say print debug player got gem. Run that again. Great, player got gem. And if we then put a gem on like it collided with another entity, like an enemy, that wouldn't happen. And this depends on the player being named player in your scene. So it's not the most resilient, but I think for now, it does the trick. Because it's clear, it's obvious. That's what we're looking for at the beginning. Now we're going to add to total collected gems, which is something we don't have yet. And we haven't really gotten too much into variables. So open global.gd. And then here at the top, we're going to type var. Var is short for variable, and it represents some sort of data that can be changed and used and displayed, modified. It's how you store things. And we're going to call that variable collected gems. No, we're going to call it gems collected. And then you can do an equal sign to assign it a value. We're going to assign it to 0. And then here at ready, we'll say print debug gems collected. And you can reference this variable in various places. So now we run our game, and we'll see 0 gems collected. In our gem script, what we want to do is when the player gets a gem, we're going to type global with a capital G to reference our global code there. And you can do dot. And we actually have access to gems collected. And we can print debug that just to show that we can get its value. Okay, we got a gem. Twice actually, because we jumped over and then fell on it. And our gems collected is 0. So what we want to do is when a player gets a gem, we want to say global.gemsCollected equals global.gemsCollected plus 1. Now, we'll do that above our print debug and we'll watch the value change. So I jumped again. When we hit the gem going up, it became 1 gem collected. Then it became 2 gems collected. I jumped a second time, 3 and 4. Now if we do step 3, we can remove it from the scene, then it won't count it twice. So to do that in Godot, you do queue free. And that says when the game is idle and it's currently finished what it's doing, remove this node from the scene. So then it can't be collected again. Now if we go back to our game, see the gem went away? Now we have 5 gems, 6 gems, 7 gems, 8 gems. Great. Let's run our game from scratch again, from 0. And now we're collecting gems. And you can see down there in the lower left, the numbers there. So let's go ahead and display how many gems have been collected. Excellent. So we can get rid of our print debug. We can also, instead of doing, well, before we get rid of print debug, let's hold on to our horses. You can just do plus equals 1. That's the short code for an item is assigned its value plus another value. You can just do plus equals. And if we run that again, oh, it's going to run the gem scene. If we run our game again and collect the gem, everything still works. So that's just a little shorter, and that's how I would write that line of code. So clear that all out. Clear out the player got gem because we don't need that, and we're feeling pretty good about that. Now what we want to do is, let's add some gems to level 2, because then that'll keep going with what we're doing. So here we've got all these gems in this list. Let's put them in a node. So you can just type node, and a node is just a generic collection of things. It doesn't do anything special, it just puts them in a folder. And I like doing that. So we'll just call it gems. Great. Now on level 2, add another node, call it gems, and then we'll click the chain link, and we'll do gem, and we'll do open. It added it to 0, 0, so alt-click, drag it, and we have our little playground level. I'll duplicate it, and we'll add 2 gems. Now if we run this level, we're not print debugging, but I'll show you another way we can see the value. We collected 2, and then we go here, we'll collect some gems. And gems will respawn when you change levels, but let's learn about something new while we're making our game. So when you're running your game, you can actually click into remote here. You can click into global, into the inspector. You can see gems collected here. So this remote tab is the running game. Godot is able to look at the data and tell you about it. So if I go here, see this 7 here? If I get this gem, now it jumped to 8. So print debugging, while nice, especially to see when something happens, if you want to look at data in your running game, you can go into this remote scene area and look at it. But when you stop running your game, it disappears and goes away because our game's not running. We also want to have a gem emit a signal that somewhere else in our code can listen and go, oh, okay, a gem was collected. Let's update the display of them accordingly. So we can actually add a signal, and we'll call it. So just like we hooked up signals from existing nodes, like, on body entered, we're going to define our own signal, and we're going to call it gem collected. And all you need to do here is type gem collected dot emit with the parens because it's a function. And then now other parts of our code can listen to see when a gem is collected and react accordingly. So let's go to level 1 and let's look at our view here. So we've got gems, and if you click into node, you see now there is a signal called gem collected. Isn't that handy? So then you could go and double click, you could connect it to level 1. Well, before we do that though, remember when we added our heads up display with the canvas layer? And we have a label that's level 1. We'll just call it level. We'll call it current level, just so it's more clear. Now let's add another label called, we'll just type in some text, gems collected. We'll just call it gems : and we'll put 0 there. And we'll drag it over here and just kind of align it and make it look nice. And we'll call that label gems. And then what we can do is we got a couple options. We can wire up these signals to say when a gem is collected, we'll go ahead and emit a signal. And then we'll listen to it and we'll update this text accordingly. So we can actually call, I think I'll call it gems label just to be clear in our code. So then let's actually go back here to this signal, double click connect. We'll just put it in the level 1 script and we'll say, remember in our inspector here, we had this called canvas layer. Let's change that to HUD. That'll make it easier to reference. That's short for heads up display. And we'll just say HUD / gems label is equal dot text. That's a property of the text value within it, is equal to global dot gems collected. And we are going to actually make it gems : space, and you can plus, and that gems collected is a number, so we can turn it into a string and add it to this string so that it displays properly and looks nice. So let's go ahead and run level 1 and collect that first gem. See how we have gems 0 in the upper left? Okay, we collect this first gem. And now we have gems 1. Let's collect a second gem. Well, that's not updating our UI even though we are collecting that gem, because we've only wired up the signal for one of our gem nodes. And that is, when we have all of these duplicated gems, that is something that we need to figure out what to do. So we've got a couple of options, and I think the way that I'd like to go about it is wiring up. So here we manually collected gem, or we manually connected gem collected to our level script. I'd like to disconnect that, and we'll connect it manually, because we want to, as we add new gems, we don't want to have to connect each one to the on gem collected. And you can actually see something else that is kind of duplicative is we have on gem collected. So let's get rid of that first one and we'll just call it on gem collected. And then what we want to do is on our ready, when it says level 1's ready, we're going to actually go and loop through each of the gems and wire up that gem collected signal with code instead of doing it by hand in the inspector. So what we'll say is $gems, and then there's a way to get the children, and that returns an array, which is a list of nodes that are its children. And we can actually say for gem in gems, and then we'll say gem collected dot connect. So remember we were connecting signals in the inspector by clicking. Now we can actually connect them via code. So we say when the signal gem collected occurs, connect it to, and we'll connect it to our on gem collected. Connected and collected sound very similar. So you could just go ahead and pass in this function name into connect, but you don't put the parentheses here, because when you're writing code, especially GD script, and this follows in other languages too, the parentheses say call this function, but you can reference a function by its name and it won't call it until later when this signal happens. So if we go ahead and just save that and run our game, run level 1, now we can go ahead and say, okay, we collected some gems, and see how gems is updating properly? That's because each of these gems that are in our game's level got connected to onGem collected, which then handles updating the HUD accordingly. Now, there are other ways you could go about this, but I think for learning purposes, to show connecting signals by hand to then connecting them via code is, and having a dynamic list of them is really helpful. And, you might even do print debug gems.getChildren just to see what that looks like, right? Let's do it together and just go ahead and look at what that looks like so you can see what a list is. So right here is what it just printed. So an array is a list, and it's usually denoted by brackets, and each item within it is separated by a comma. So you could have an array too that's like 1, 2, 3. And in our case, we have a gem. We have an array of the gem nodes. And so this says for each gem in that array, that list, run this code on it. And this gem here that we define, that's something that we type. We could name it, we could name it whatever, pool. And then if that was named pool, we just want it to correspond there. And so now we're collecting the gems. But let's go ahead and run level 2, and you'll see that, this is going to run level 1. There we go, we stopped that. If we collect these gems, we don't even have the gem count there. So it's not going to update and display, and we're not connecting those gems properly. So we've got a couple of options here, as always. We can do a couple of things. And how we go about it is ultimately up to us, but I think what I'd like to do is, see we have this HUD here and we have gems label. You could copy it, paste it, copy this code again on ready to manually connect it and add this here. But that quickly becomes pretty brittle, because every time we make a level, we have to make sure we wire that up properly, which that's not what we want to do. So what we can instead say is, we can take our HUD and how do we want to go about this? This is where, Godot and making games becomes a little bit more complicated. One option is that we could have this level 1 and level 2 script, because they are quite simple. We could have them share the same script, and then that would mean that the same ready works. And I think that feels pretty good to me, and then we can make HUD a shared resource accordingly. So let's go ahead and do that. So we've got our level 1 script. We can go and we actually have to do it down here, and we'll rename it to be just level. And now here, Godot automatically connected level. When we renamed it via the resource manager, it automatically changed the one that's connected to level 1. And we can say here, we can export a variable, and we'll just call it level num. And let's see, it needs an initializer. So that's saying you can't just say that without assigning an initial value. So we'll set it to 0. And what this does is that when we attach this script to any number of levels, which we will do, we just want to be able to know which level we're in so that we can set the level HUD and we can set the this print even, and we can set which level to change to accordingly. So by saying export variable, when we click into level 1 here, this node, now we have a number here called level num. Godot automatically translates that. So we're going to change it to 1, and this only changes level num for this instance of a node using the level script. Now if we go to level 2, which you'll notice that our door changes to level 1, but other than that, it's pretty simple. So we can actually delete the level 2 script, and it warns us that it's connected, and we know that, and that's okay. And here we can even detach the script, so it's not there. Now let's attach a script, and instead of having it create level 2, we'll connect level.gd, click load, and now you'll see when we click level 2 in the node scene, we've got our level num, and you can change it accordingly. So now we have one script level that's sharing the functionality accordingly. Now there's a couple things that we want to do. It's always going to print level 1 ready. So if we run level 1, see it says level 1 ready down there in our print. Now let's run level 2 and see what it prints. Level 1 ready. Let's make it so it prints our proper level number. So remember before we did this, we added some strings together. Got to convert the num to a string. And you can then concatenate is the fancy word for this. So you can concatenate strings together to compose them. So now see down here, level 2 ready. And we've got the HUD showing the level number is working properly. So because those are our canvas layer is different, but we're going to actually make HUD a shared node and reuse it in our levels, which is really really nice. But there's something else that we need to fix, because if we go to this door, did you notice that? It's just automatically loading level 2 because we have hard-coded the game to always change the scene to level 2. Any door will change to level 2. So we've got options here. We could make the door, and we could set the property. So how did we work the door, right? Let's open here, and door is just it's an area 2D. So we have that event, and we say on door body entered. We could connect. We got a couple things. We can make a door go to a specific level. Or we could always say, the door of a level goes to the next level. Let's make it so that doors have a property of which level they go to. So click into door, attach a script. We'll call it door.gd, and we can remove these. And again, we'll do export var, and we'll call this, level, like a door goes to a level. And we'll just assign it. We can make it we've got a couple options. Let's go ahead and we'll do the simple thing first, which is just we'll make it an empty string. And then we can explore some other options potentially. But for now, just make it empty string. Then if we go to level 2 and look at the 2D mode and scroll in and click our door, you'll see that there is a level field here. And we want this to go to level 1. So if you right click the level 1 scene and you say copy path, and then click into here, this new level exported variable, and paste it, it says res : level 1.tscn. So go ahead and save that. And then click our level script, which is our shared level script. And Now it says on door body entered. It sure would be nice to know the door here. I'm not sure if we can get that. So let's quickly see something. So we have door here, and it's a node, and we have on body entered. We can double click. We can't double click that. We can right click and click edit. I just want to see if there's a way to know the door that that we're having connect. There's not. So what we want to do is, in addition to our export variable for level, let's add a signal to door, and we'll call it entered. And that will emit a value of the level we want to switch to. And then we'll connect the door body entered. Now this is, we're editing the instance of the door. We actually want to edit just the scene. So I clicked into the scene, and we'll say body entered door, and we'll say here, we'll call it player entered. And remember in our code, we check if it's a player, and there were a couple different ways we did that, right? Oh, I think I maybe deleted the part of that code, but where we were checking if the body is of type player, but we'll go ahead and we'll say if body dot name equals player. So we have to have our player be named player. We'll say player entered emit, and then we'll pass the level variable that we have set. So then we've just connected a signal to emit a custom signal that has the data that we need in our game. And then we'll wire it together. So let's go back to level 2. We've got our door here, and we're going to actually disconnect this on door body entered, and we're going to reconnect it on player entered. And we're going to say, it's called on door player entered. We don't need to check that it's a player because we know that it's a player. And it automatically adds this level parameter, which is the value that we emitted here when the body enters, because each door is now going to track which level it should change to. And when a player enters the door, we need to know elsewhere in our game code which level to load. And instead of having the door handle switching the level, we'll have the level handle switching levels. So we're taking the signal and we're communicating upward. Now we're going to go ahead and we'll delete on door body entered, because now we have on door player entered. And instead of hard coding it to level 2, we can just say level. So, and this is indented one extra. So now our level script is responsible for handling switching levels. And this is preferable because, and maybe in the future, as your game gets more complicated, something else would handle it. But for our case, now we know that the level handles switching it. And I guess you could make the case for switching the level here, but it just, to me, that just feels like not the responsibility of the door. The door just needs to communicate upward, hey, something, a player has entered. So I know that we just went forward quite quickly, but we're kind of piecing things together so that we can share this level script, which will then let us share the gem collecting in the HUD. So let's go back to our 2D view, and we're in level 1 now. Let's connect this door to go to level 2. So we'll disconnect this one. See this one that's yellow? That means that it's connected to the root scene that, the shared portion of every door has that called. If we double click it, you see it goes to the door GD script. But anyway, let's go to the inspector for our door. We want the door in level 1 to go to level 2. So you right click, copy path, and paste it in there. And we've got level 2 there. Let's see if that works. Go ahead, we'll run our game. It's going to run level 2, and that's okay. All right, we've got an issue here. It's saying invalid indexed text on base null instance with value of type string. So it's trying to get HUD gems label, but we're in level 2, and you'll see we don't have that there. So we can actually copy and paste gems level, and we'll go back and we'll make this less duplicative, but let's also rename this to be current level. Rerun the game because it ran into an issue. And let's go in that door. See, now it brought us to level 1. Let me move my mouse cursor. Okay, that door to level 2 didn't work, so let's figure out what's wrong there. So that was in level 1, and we set our door to go to level 2. Seems like it should have worked, but let's see what happened. On door, player entered. Maybe we need to connect this. Aha. And this sort of like, forgetting to connect things, that's something we could remedy with a script. But for now, I think this works well for our needs. And maybe when we get to level 3, let me make a note. We'll connect door player entered signal with code, just like we did with our gems. So let's go ahead and run our game and make sure everything works. We'll start, we're running, we've got our gems collecting, great, that's counting properly. I just fell off and there's no good way to reset, so we'll add that in a second. Go there, level 2, great. Gems was updating properly because we added that, label node accordingly. But did you notice that when we went to a new level, even though it's keeping track of our gems, it shows 0 gems until they're connected? We'll want to, really quick here, we'll say HUD, we'll just say set gems label. And we'll define a custom function ourselves that does this code. So then we can call it from multiple places. So up until now, we've primarily been using functions that Godot comes with or that Godot generates. But when writing scripting code, you often want to have something happen multiple times based on different logic. So when the game is ready, we're going to set this label to however many gems you have collected. And then anytime a gem's collected, we'll update the value. So now if we run level 2, you'll see gems is 0. I'll collect a gem. Move in the door, gems still stays at 1 because when level 1 was loaded, onReady was called, and it went and said, oh, okay, let's set that HUD value accordingly. And that does that. So we've got our HUD that's duplicated, and we want to make that better because right now, every time we add a level, we'll have to go and update this to say level 3 or, update the label accordingly. And let's go ahead and make that better. So go to HUD, right click, save branch as scene, and we'll just call it HUD.tscn. Save this. And now here you can see HUD.currentLevel is 2 and gems label is 0. And you can keep it there just like that to have it be like a mock-up. But we're going to then set the value with code accordingly. And we're even going to define functions on our HUD that let us set it externally more easily. So we'll create HUD.gd, and we're not going to do anything too fancy here. And we'll just, instead, we'll say, we'll add a function called level, and we'll just say number, because that'll be the level. And we'll say HUD.current level. We'll actually copy the code from level.jd, because I think that's quite nice. Oh, we don't have that code yet. Sorry. So we'll say HUD.current. Oh, we don't even need to do HUD. We can just say current level dot text is equal to a string of level colon and then space. And remember, num is going to be a number, so you just convert it to a string. Great. And then we can say func gems, and we'll count them, right? And we'll say current level. Instead of current level, we'll say gems label dot text is equal to gems colon, and then we can even just keep them both called number, those parameters. And then in our level code here, we'll say, instead of printing here on ready, we'll just say HUD, and we'll call that new function, which was level, and we'll just pass in level num. Great. So that sets that there. And then in set gems label, instead of saying HUD gems label text, all we need to do there is say HUD.gems and pass in the number of global gems collected. You could, instead of passing in the number, just get it from global, but we don't necessarily know we'd always use global. And I think it's better to have, our little scenes that we compose our game with, try to be as encapsulated as possible and receive the data through parameters rather than accessing global resources. But, just know, could have done it that way too if we wanted. So let's go ahead and run this, test it, see if it works, because we just changed a bunch of things. So level 2 worked, gems are 0, and if we've got an issue here. So we loaded level 1 and we called HUD. And it says non-existent function level in base canvas layer. That's because in our level 1, we're using our old HUD. So we can actually delete this node. That's not the HUD that we created as a scene, that was the old HUD. So now we can click the chain, click down to HUD, and add a HUD. I'll just drag it up here just to make it easier to see. Now this is our shared HUD, right? You can see that because of the movie clapper. And it has our shared script. So level GD will work automatically for any level we create now, right? And I know that seemed like we just took a bunch of steps pretty quickly, but what we did was we made it so that each level has one shared script. And that shared script makes it a lot easier to add level 3 in the future, and just makes it, it'll just make everything feel a lot better. And now you can see level 2, and it's keeping track of our gems. We can switch between our levels. That was a really big step we just took in all of those ways. So let's go back to the to-do list. Congratulate ourselves because that was great. And I was thinking about I've got ideas for like what you can do when we're done. But, and instead of deleting that, let me put it down here at the bottom. So let's go ahead and add some sound effects, and we can add a music track. We can also, let's make it so we can reset the level really quick, actually, because when we die, that doesn't feel so good. Connect door, player signal entered. Oh yeah, that's maybe something you could do, right? How would you make it so that you could connect your doors with code signals rather than connecting them manually, right? Just like we did with gems. So that's something you could do. You could make player movement feel better with acceleration and drag. That would be good research to learn on your own. Yeah, we'll add a full screen setting just for fun. And yeah, we're getting really close. We're getting really, really close to the end. So let's keep going. Level reset. Okay, so let's make it so that in our level code, right, we have our level script. If we jump off the end ledge, we don't have to quit to restart. Let's go ahead and add a quick input map for that and have that work accordingly. So we'll add a new action called reset level and click add. And I'm going to map it to the R key. And I'm also going to map it to triangle on the Sony PlayStation controller, Y on Xbox, and just hit OK. Great. Then in our level code, we can say func input if event is action pressed, and now we've got reset level as an option. So we can call get tree, that gets the tree, and you can say reload current scene, and you can have it call that right away, but it's generally best practice to say call deferred, and that's much like queue free happens when the game loop's idle. You can call deferred there. That way, if there's any data that's saving or being accessed, it doesn't create any issues. So now if we run our scene and jump off the ledge, if we press R, our player responds right there. And maybe you could build a game around like making it really easy to reset your game. And when we reset, our gems doesn't get reset. So if you wanted to do that, you would just say global dot gems collected is 0. And you'd also want to set gems label. And then how could you write a function that does both of these things in one call? That would be a good extra credit too. But let's go ahead and collect a gem, and then we'll miss our jump. Now if we press R, it resets. A good bonus extra credit too would be make player reset when they fall out of the level bounds. That's a little bit more advanced, but it would be something I think you could figure out given the things we know with Area 2D and stuff. So let's move that down here. Let's add a sound effect for when the player jumps. So I like to use a tool called JSFXer, JavaScript Sound Effectser, which is at sfxr.me. It's a free sound effect generator, and it's generally retro sound effects that you can just click it, and you can adjust the sliders too. I like that one, and you can just play it over. You can mutate it, changes it slightly. Ooh, I like that one. Okay, and then you just click download. It creates a .wav file. And then you can just take this .wav file, go to Godot, make sure that you can see the resource area. You can just drag it in. Now you have jump wave. And you can double click it and play. You can hear that. Great. Now we can go into our player scene, add a child node, and if you just type sound, audio I mean, not sound, you got a bunch of options. Audio stream player, 2D, audio stream player, 3D, and audio stream player. The 2D and 3D versions set different properties, notably the volume, based upon how close you are to the item emitting it. So imagine you had like a boombox or a speaker in a game. You would use 3D or 2D, depending on the type of game you're making. And as your player gets closer, it would sound louder. For our case, we don't need that. So just do audio stream player regular. And we'll rename this to be jump SFX. And over here in the inspector, you can do quick load, jump.wave, and now it's loaded into the sound effect. You can test it and play it. You can change the volume in decibels. So like if it was too loud, you can make it -2 decibels. And here, see where we say if it was just press jump and you're not on the floor, set the velocity to the jump velocity. Now all we'll do is we'll just say jump sfx.play. And that's a function, so you put the parentheses. Now if we run level 1 and jump, oops, I started the full game, and jump, we have a little sound effect. Great. How could we make it so that we have a sound effect for the gem? Well, there's a one that might be called like, pick up coin. I like that one. So click it, save it. I'm just gonna call it gem. I just renamed it quick. Drag it in. We'll do the same thing, right? That's what this is all about. It's just practicing. So here we have on body entered, player, gem collected emit, and then we can say, we'll add a new audio stream player to our gem, to the, the gem root scene. We'll go ahead and quick load, and we'll call it gem, we'll call it collected sfx, and we'll say collected sfx.play. We'll run our level 2 just to test that one. And you might not have heard the sound effect play for the gem. Why would that be, right? Let's talk through that. So we cue free. So the first moment it can, we say cue free the gem. But then we can't play the sound effect. So there are a couple of options here. We could remove the sound effect when it's done playing. Sorry, we could remove the gem when it's done playing. That's one option. You could make it so that the gem collected sound effect gets emitted, which we already have, and then someone else handles playing the sound effect accordingly. We're going to do the first one because I think that will show us a couple new concepts. So click into collected SFX and say connect finished, and we'll connect it to the gem script. So on collected SFX finished, then we'll cue free. So we won't cue free until the sound effect is done playing. Now if we rerun the level, we should hear that sound effect. Did you hear that? But you might have noticed that the gem is still visible even after even after we collect it. Let's fix that. All you have to do is call hide. It's a function that exists and it hides itself. So instead of essentially removing the gem from the game, we hide it, we play the sound effect, and then when the sound effect is finished, we use that signal to say, okay, call cue free, which then removes the gem. So if we go ahead and rerun our game, now we've got a sound effect for the player, we've got a sound effect for the gem. Oh yeah, this also reminded me of, let's, as part of cleaning things up, let's go and we'll add level 3 at the end because that will be fun. The quit option, we'll add that. That's easy. And then we'll, I want to make it so that switching to levels with a nicer interface. Okay, sorry about that. I just remembered that. So we've got SFX jump and gem done, right? That wasn't too bad. I really like this tool. It doesn't make, super modern sound effects. They're very retro, but I think that can work really well. Music track. Okay, so music is always interesting because, it takes time to make, but we'll go ahead and we'll just go to OpenGameArt and find one that we can use. So here's one by Wolfgang. It's an 8-bit theme. And it has a license of Creative Commons to give attribution. So you would say this is by Ted Kerr, and yeah, we can go ahead and add that into our game. So all you do is from OpenGameArt or wherever you find your music is we'll use the .ogg. So .ogg is like it's an open source audio container format, and it's much smaller than .wave. So here, the .wave is 6.6 megabytes, and the .ogg is 2.1, so it's 3 times smaller. And compared to MP3, MP3 has some proprietary licensing, so .ogg is preferred, and Godot plays .ogg. So you just drag it in, and it imports it. You can double click it and play it. It's 74 seconds long. That's nice. So then in our level, we've got some options. We can have a different level, like a different theme per level. If we wanted to do that, we would have to go and find a second audio track. Let's actually see if Wolfgang has another one. Here's a quirky waltz. That's really fun. It's only in .wave, so we'll just have to use what we've got. You could convert it. Maybe, this one has an MP3, but, oh, that's kind of fun. Okay, anyway, we'll make sure we give Wolfgang credit accordingly, too, in our game. But, Annoying Waltz is, it's a bigger file, and, that affects how fast your game loads, but, nonetheless, we'll use it. You can say whether or not you want it to loop, so we'll get into that in a second. Let's see. So, okay, sorry. Let's go to action theme. I'm getting a little bit ahead of myself. Click into action theme and click import, and we want to loop it because it's music. Then click re-import, and now it will loop. We're going to do the same here. I'd like to do the same, but maybe we can't. Oh yeah, detect. Forward. Now it should loop. So, okay. We're going to get into learning a couple new things here as we play our sound effect. So, we're going to add another audio stream player to our level, and we'll call it music. Here in our stream, we'll quick load, and we'll go ahead and we'll quick load action theme for level 1. And we already set it to loop. We're going to click autoplay so that it plays automatically when it's added. And we might need to adjust the volume, but that will automatically play it. And I think that will do the trick. Great. Got some music playing. It's a little loud, so even while it's playing, you can come over here and drag the decibels down a bit. It's still a little loud for my taste. And it's a little too soft, so -8, that's sounding pretty good. But then level 2 doesn't play any music, so all we do here is add audio stream player, music, and we set the stream, quick load, we'll make it Annoying Waltz. Now if we go ahead and run level 2, it's not playing, and I don't know why. Oh, because we didn't do autoplay. So you gotta remember to do autoplay. And it's a little bit hot. Okay. And then we go to level 1, and it automatically switches. So now we have 2 levels with different music that autoplays. Cool. That was actually really easy. Let's make sure we give Ted Kerr credit. So I'm going to copy their name. And then in our main menu, we'll go to 2D, we'll add a label, and we'll just say music by Ted Kerr, and we'll also say sprites by Kenny. Even though the Kenny assets are public domain, I really like to give credit. Even if credit is optional, it's really good to be in the habit of giving credit to people. I really think it's super generous that people make these free assets to use in games. So we've got sprites by Kenny, music by Ted Kerr, and we've got a game, right? Like, isn't that cool? And when we press R, it resets the music, which is cool, just like our level. So you could go and, we got music. Let's figure out our next step. So we want to focus on the main menu buttons when we launch the game for controller support and keyboard support. So right now the start button only hovers and is interactable when we hover over it with our mouse cursor. But there's a way to make it focus automatically, and then it becomes controllable with our keyboard and gamepad. So I've got my PS4 controller that I just want to use to test it out. And what we can say here is in our main menu script on ready, we can grab the start button. There's a focus. There's a grab focus function. And that says when our game is ready, grab focus of this. And you can now see there's a white outline around the start button. And if you press the enter key, it goes ahead and triggers it. And when we press escape, it's focused again. But you'll notice that the gamepad doesn't work. So this is where we go into input map and we show built-in actions and see UI accept. We're gonna wanna go ahead and make it so that that works with our other keyboard mapping. So I'm gonna make J, I'm gonna make Z, and then I'm gonna make the X button on the PS4 controller, Sony Cross, work. Now if we rerun the game, I should be able to press the X key and our game starts. And I can go back to the main menu and it's focused. So that is there. Great, that was easy. Now let's make it so that we can toggle full screen on a button press. This will be pretty simple, and you can make it more advanced, and you could even have it save to a user setting. I have a project called Godot Skeleton. That's a starter kit for your games that handles this kind of stuff, so you could check that source out if you want to see how that's done. For our case, we're just going to go ahead and add a real simple one. So in the main menu, just duplicate start button and say, we'll call it full screen button. And we'll drag it down. Whoops. Just drag it down. I'm holding Alt. And we'll just call it toggle full screen. Great. Now if we run our game, we can't move up and down to toggle full screen with the keyboard and the controller. But there's a way to make that happen. The way we would do that is we can actually add a child node called vFlowContainer. That's vertical flow container. We create that, drag these, select them, drag them within it, and just call it options for menu options. And then we can go ahead and make it so that if we make this taller, however tall we want it to be, and then however wide we want it to be, the options within it automatically stack. And that's useful in and of itself, but because they're connected via the vFlow container, we can use our keyboard and game controller to move between the items, but now we have an issue, and you can see that start button has changed its location, so we just need to update our code there. Now if we press down or up on our controller, it goes and grabs focus of the next one. And I did toggle full screen and it started the game. That's because our full screen button has pressed connected to on start button pressed. So disconnect that, connect this here. We'll just connect it in main menu on full screen button pressed. Godot has an option called a class called display server. You can do window set mode, and there are a bunch of different window modes that exist. Exclusive full screen, maximized, minimized, windowed. And what we want to say is full screen. And now if we save that, run our game again, and press that button, it went and made the game full screen. And you might notice a couple of issues. One, now the game's only in the upper left corner, and if we press it again, it doesn't toggle it back. So we can do a couple things. There might be a way to say display server dot get window get mode, and that gets the mode of the window. And we can do print debug to see what that is. Just out of curiosity, it's probably an enum. Yep, so it's 0. And then if we toggle full screen, toggle it again, quit our game, it's set to 3. So we can do this. We can say if window.get mode equals display mode. Let me expand the code since we're coding so much. Then we'll set the mode to display server dot window mode window. I forgot my colon at the end here. If the display mode server is window mode windowed, then we'll set it to full screen. And I think full screen is preferable to exclusive full screen because exclusive full screen can, I think it affects the resolution in a way that might be undesirable for your host operating system. So now if we go and toggle full screen, we can toggle it back and forth. And that's pretty nice, It'll always launch windowed, but if you wanted to change how your game launches, you would just do this in our global ready, but I don't want to do that, so we'll leave it. But so that's that. Now we have full screen toggling, but we notice that it scales funny. And if you take your window here and scale it, it's kind of weird, right? The level gets cut off. That's not what we want. We want the game to actually get smaller with it. So we can go to project settings, and in general, there's just a ton of different project settings that you have. You can set your game icon, which that would be kind of fun to do. We'll do that at the end. Let's make a little to-do. But what we want to do is go to display window. And this is also a place where you can change how it launches too. So you could do it in your settings or you could do it in your code. But we're going to leave it as is. But what we want to go into is stretch. And then in stretch mode, it's disabled. I think we want to do stretch viewport and keep the aspect ratio. So now if we run our game and we change that, see how it scales and we get the black bars, the letterboxing? That's preferable for this type of game because now if we make it bigger or smaller, the game reacts accordingly. Now for some reason our toggle full screen button doesn't work anymore. So let's try to figure that out. Maybe it was just being funny while we were changing that. So now we can toggle full screen. We scale the window size accordingly. And you might notice text gets a little blurry when you scale it. I truthfully don't know how to fix that at this point. There might be different ways to do it. I'd have to do some learning. But it does, text does appear to get a bit blurry and pixelated. If you used a pixel font and you scaled your game like this with that viewport setting, that would look pretty nice. So I just want to see something really quick. If we did mode canvas items, Let's just see what that does, because I don't even know. Oh, everything looks a lot smoother with the text. So I think we're living and learning. Well, that's awesome. Let's figure out what that does. So, Godot mode canvas items. Let's see what that does. Okay, so Godot has some recommendations for non-pixel art. Use the stretch mode canvas items. We're using pixel art. For pixel art, change the stretch mode to viewport. Let's link to this in the description. I think that's quite helpful. So I'm going to leave it as canvas items because I think it makes the text look a lot bigger or look a lot better, but change it as needed. So we've got our full screen setting. Let's put that in done. Now our next one is we want to add the ability to quit the game, and also we only want to show that on the web, on desktop, because in web builds you can't quit it. You would just close your tab. And also full screen toggle on web is a little different. itch.io, where we'll host the game, will handle that for us. So we're going to hide that on web browsers too, our full screen toggle. So let's go to our 2D view, and here in our options button, we'll just add another button. We'll call it quit button. We'll give it the text quit. And in our node, we'll say pressed, on quit button pressed, and you can actually just do get tree. You can call the quit function. So now when we launch our game, we can navigate down and quit the game. That's kind of nice. I also missed a couple of input maps. So let me just go ahead and, you might need to add it for UI left, right, up and down, because I want to support WASD. I'm just going to map these really quick, because these are the built-in UI actions. And UI up. I just noticed because I pressed WASD to navigate the menu and it didn't work. So now we can quit. Great, but let's make it so that our quit button and our full screen button are hidden if we're not on the desktop computer. So Godot has this handy check. We can say if in our ready for main menu, if OS has feature. And there's a feature called PC. Now if we run that, PC gets output. So we know that we're on a PC. And we can click into here, has feature, and we can refer to the feature tags document to see what exists. So you can check if it's debug, you can check if it's desktop or mobile or web. And what we checked there was PC. So if it's a PC platform, desktop or laptop. If it was web or mobile, it would return false. And if you're on a mobile device, you usually can't toggle full screen. And if you're on the web, you usually can't toggle full screen. So we'll say if it does not have the feature PC, then we will say full screen button hide. So, and we'll also do quit button dot hide. So now those will both be hidden only on web and PC build, or web and mobile build. So anything that's not desktop PC. And we'll see that when we upload the game to itch. But for now, just know that that's there. Okay, great. We've got the quit option. Let's set the game icon. Let's make a level 3, and then we'll export our game and upload it. And then let's go extra credit. This will be advice for where to go from here. So, okay, let's do set the game icon. So in our downloads, you can see there's a folder of just tiles. And let's pick one from default that we think represents our game. And I'm probably going to pick one of the players because I think that's fun. So here's one with, but I don't remember which player we used. Let's play the game and see. Okay, so it's the one with the curled horns. See how these characters have different horns? Oh my gosh, it's really hard to find things. Okay, here we go. We'll make this our icon. So I've just copied that. Or no, I'm going to click it, drag it into our game. And now you'll see tile 241. I'm going to rename it to be icon.png. And then I'm going to delete icon SVG. Also, I'm going to stop running the game. A nice thing that you can do as you're working on a game, especially if you add music, is add a setting to turn music on and off. Godot Skeleton, which I mentioned, also has that, which can be really handy while you're developing. So now you go to Project Settings, go to General, go to Application, Config, and for the icon, just go ahead and select icon.png. Close it. Now if we run our game, you'll see that the icon is our little icon there. And you may have noticed that it's a little bit blurry, and that is because it's taking it and scaling it up. So got a couple options there. We can do open an external program. Wow, didn't like that. We can do show in file manager, and we could open it, and I'm going to open an aComplete, which is a pixel art editing tool. I'm going to just do file, export, and I'm going to export it at 1,000 times its normal size. I'm going to export it at 10,000 times its normal size, actually. And I'm going to save that here and overwrite it. So now, it's not bigger. We could do this image, right? I'm going to make it 16,000 by 16,000 and save it. Got a little bit blurry in certain spots, but should be, now it's quite a bit bigger. I think that was an aComplete issue. Delete this duplicated one. And now we have icon PNG. If we re-import that, run it again, it should look a little bit better. So now it looks a little bit bigger. Sometimes with pixel art, you gotta expand it for these icons to make it look good. So now we've got an icon. And let's add a level 3 really quick. And I think part of your job as the game developer and the level designer is to make the levels much better than I did. So, my levels aren't very good. So you want to make your levels better. Let's take level 2. I'm going to duplicate it. We'll just make it level 3. Double click it and make sure it's open. And, we have this door here and it says level 1, but maybe we want to make this say level 2, right? And then remember how we changed which level we go to? We just go ahead and change that there. We've got these gems, which we'll add. We've got our player, which is fine, but let's go and edit the tile map. So just like before, we're looking at our tile map. You select some tiles, and then you can just draw them on there. And we want to make them look good. When you're in the tile map editor, you can right click to delete whatever tile's there. You can just paint like a paintbrush there. And yeah, I'm not feeling very inspired right now to make a good level. So I'll leave that to you to do. But let's duplicate these gems and just make sure everything works, and we'll play test our level. All right, and let's rename this node level 3 just so it matches. Now we can run level 3. Now we can go to level 2. But in level 2, let's make it so that we can go to level 3. So we'll just add another door here to level 2. Go into level 2. Go to door. Door needs to be duplicated. Drag it here. Change the label. And we'll make it go to level 2. Save that. It automatically updated, so we could have tested it. Okay, that seems like it's not going to the right place. So let's go ahead and see what that is about. Let's just rerun the scene because maybe it has to do with Oh, it's because I set it to level 2, but it needs to be level 3. Also, something that I'm noticing on level 3, sorry, I'm a little all over the place, is that our HUD is that we didn't change this number here to level 3. So now that it's changed to level 3, and if we run level 3, in the upper left, we'll see the proper level. So yeah, I think that's how you add levels, you know? Pretty quickly, you can just go, drop in a level, make sure you connect the doors or whatever it is you need to, and change the data, but yeah. That's, I think that covers that. So we've got level 3. Now these levels aren't very good, but I think the pieces of the puzzle are there to do it. So let's play test our game, and then let's go and upload it to itch, and we'll talk about exports. So I'm just going to go ahead and I connected my controller, press the play button, and we'll give the game a test. So I'll toggle full screen, make sure that works. Okay, and let's start the game. I'm gonna move my mouse. You can hide the mouse cursor too if you wanted. There's an option for that. And then triangle resets the current level on my controller, or the R key does. But yeah, that's feeling pretty good. And then let's do one little thing I noticed is in the main menu scene. Let's add a credit for ourselves. Gained by you. So put your credit there and do that. And now we've got a game that we can export and share on the web and with our friends or whomever, players. So what you want to do is go to Project and go to Export. And we're going to configure exports for as many operating systems as we can. This interface is a bit overwhelming at first, but we'll get through it without issue. So click Add. You'll see all the options you can export your game for. Let's click Web. I'm just going to say it can't find export templates. So click this, Manage Export Templates. And you need to download the export templates for whatever version of Godot you're using. And it downloads nearly 750 megabytes of data. This is the different templates for each operating system. So, for web, for Linux, for Windows, for Mac, Android, iOS, there's like basically a wrapper or a shell that has Godot compiled for those operating systems. And it takes our game data in here and builds our game using them. So while Godot, the program, is pretty small, we need this export data in order to share our game with people who don't have Godot installed. And it takes a little bit of time, but not too bad. And then it says, okay, they're installed and ready to be used. You can close that. Then we go back to Project, back to Export. Our web export's still there. And now we need to go and click here into Export Path and tell where we want it to export to. I like to create a new folder called Exports. And then within there, I'll create a new folder called Web. And then within Web, Name the file index.html. This is what itch.io needs. Click Save. And then there's a bunch of other settings too. And I'd say don't worry about those quite yet. Those things that we just did, just where to export it, naming it properly, index.html and web, that's all you need to do. Then, depending on which operating system you're exporting your game on, you can export for other operating systems. A kind of funny thing is that on Mac OS, you can export it for pretty much all the major operating systems, whereas on Windows and Linux, you can't export it for Mac. So there's some weird things there. And then now you'll see for our Mac OS runnable path, I'm going to put it in exports. And I'm just going to call it 2D platformer mac.app and save that. Again, there are other settings, but if you're on Mac OS, you have to set the bundle identifier. So you can just do like com.yourname. Some kind of unique identifier. That will do it for Mac. I'm going to do it for Linux. And then here, again, sorry, this window gets really unwieldy sometimes. Click into here. Instead of 2D platformer Mac, I'm just going to call it 2D platformer.linux.x86_64. That's just like the Godot's file extension for Linux. And I'm going to leave these things here. And you can embed the PCK. The PCK is your packaged game files. And if you just want like one file, one executable that you can send to someone, you can embed the PCK. And you can do that in Linux. You can do that in Mac. Or you can not embed it. Up to you. I'm going to click embed so that we just have one easy file to distribute. And then Windows Desktop is the final one. I'm going to embed the PCK. I'm going to set the export path to instead be 2D platformer Windows. And I'm going to make that a .exe because that's the Windows executable name. And now we have all of our exports configured. And you can export them one at a time by clicking Export Project and unchecking Export with Debug. Or, now that we have them all configured, you can click Export All and do Release, because this is our release build, and it will go and export your game for all of these platforms. And there might be some warnings, like there is for Windows, but it completed them. And now you're like, whoa, my game's exported. So you have to go into your game folder and find that exports folder. And you'll see, here's our game. We have the Mac version, the Windows version, the Linux version, and the web version. If you clicked index.html, it's not going to work because you have to properly set up your web server for serving it, but it'll work when we upload it to itch. So let's just double check that the game works on our platform. I'm on Mac, so let's just make sure that works. Okay, yeah, look, I can just run this .app file, and I can toggle full screen, I can run the game. Awesome. That means I could go and send this to a friend. And then what I'm going to do is I'm going to compress all of these into zips so that they are smaller and faster to download for people, and it will upload faster to itch.io. Because out of the box, Godot games are pretty hefty in size. Like if I look at the Linux build, it's 76.8 megabytes. The Mac build is 145 megabytes. It's pretty big. But if I look at the Mac app now, compressed, it's almost 2/3 smaller, which is, pretty considerable. So that is a downside to Godot web builds, or Godot builds, is that they are quite a bit bigger, especially in Godot 4. So you go into the web folder and don't compress the top level folder web, compress all the files within it. And then I like to rename it 2D Platformer Web. And I'm going to move this up to my exports folder. So now when I go here, if I organize these by name, let's actually organize them by kind. We can see all these zips here. These 4 zips, we have Linux, Mac, Web, and Windows. We're ready to upload them to itch. So what you do is you go to itch.io. Let me close some of these. I'm going to save this feature tags to put in the video description. And you go to itch, you can create an account if you don't have one already. Itch is a website for sharing games. And you go to your dashboard. And then way at the bottom, you can do create new project. And I'm going to name this Godot 2D platformer. It will automatically create the URL. You can add a description, which is great. And then for kind of project, you're going to select HTML because we have an HTML build. If you made a game and you didn't have an HTML build, you would just say downloadable and that your players are going to download it. And then make it whatever you want it to be. When you're working on it right now, it's a draft, so no one will see this. For me, I'm going to make it prototype because this is just for learning and teaching. And you can click upload files. You go, take these files, select them, and then Godot is going to go ahead and upload all of those in parallel. And anytime you want to release a new build, you would export all, compress them, and you can actually configure your exports to go to zip right away, but I noticed a couple of weird issues with that, so I usually do it myself. And then you would go and upload it, and Godot would, or Itch would know to do that. Now there are a couple other options here. The Godot skeleton project I made has a script to automatically handle creating the export and uploading them. There's also an add-on for Godot for uploading to Itch. Haven't used it myself, but it seems pretty nice. And so this is the most like bare bones, slightly cumbersome process, but I wanted to show you it because this is, you can automate it and make it better. And then you go in and you select the platform for each one. Linux is the little penguin, Mac is the apple, web is, you just leave it as is, but you say this file will be played in the browser, and then Itch knows to load that. And then you have your Windows. Here we can go ahead and set our size of our game. In Godot, in our project settings, down in window, there was a default size for our game. And so I like to mirror that on Itch. And then if you wanted your game to launch smaller, you could just change it here. But remember, our game will scale, so you could make this a different size, but let's just stick with that for now. And we can add a full screen button to make sure that the game could be made full screen. Add a description. I'm going to add a genre of platformer, and I'm going to add a tag of Godot. And so you'll see it's draft. So if I save and view page, it brings us here and it says loading game for the first time. And I can click run game, and you'll see there are a couple of issues. So we actually have to go back to edit game. And you have to, for Godot 4, click shared buffer support. Experimental, you have to enable that. That's what allows our game to run in browsers. I'm going to zoom out a little because my computer's resolution is really small. Now this final step takes a long time on Mac operating systems. On Windows or Linux, the game would have already loaded. And also know that with Godot 4.0, Safari web builds, like web builds, don't work in Safari. It's just an issue with Safari that is out of Godot's control. But if you were on Windows, or if I was on Windows or Linux, this would be faster, and that's nice. But while that's running, you can now see someone could download your game, and they have access to the different files based on their operating system. I'll even show you in the Godot desktop, or the Itch desktop app, where you can go ahead and download and play a game too. I'll just do that while it loads because it does take quite a while. So Itch has a cool desktop app for games that you can just install easily within the sandbox of the Itch app. So let's go down and find my platformer game. It might be at the top. Let's see. Platformer. Godot 2D platformer. Then I can click install, and it says not found because it's a private page, but it automatically finds the Mac app and will start to install it. I can launch it, and it launches our game. So, a friend or whomever could find this and play it. It seems like the music's playing twice. Well, that's odd. But now you'll see that our web version launched, and we don't have our icons. we don't have our buttons for quit and full screen because we're in the web and full screen works differently. We can click start and our game plays and works in the web. And then, you know, you could share this game with your friends or keep working on it. That is a Godot 2D platformer from scratch. I hope that was fun. I hope it was helpful. There's a lot of different moving pieces to making games, and I thought it would be helpful to show from start to finish how to do that. So now that we've got this done, let's talk about some things you could do from here. So you could instead... No, I don't even know what that is. Let's just get rid of that one. I forget the context there. So one thing that I've noticed is that the player movement feels pretty bad. The way the player controls just feels real slimy to me. And you would want to make your player movement feel better. There are a lot of options here, and I think part of learning game development is independently researching and figuring this stuff out. I have a project on GitHub called Godot types where I have smoother platformer movement. I would recommend looking at that if you need some guidance. But right now, the way that this moves is that once you press a button, we just immediately apply the full speed. So your player goes from 0 to full speed real quick, your playable character. You would want to add some acceleration and deceleration and some drag. That would make the platforming feel a lot better. You could do variable jump height, like Mario, where when you hold the button, you jump higher, but then there's a ceiling to how high you can jump. That would be pretty interesting. You could make it so that the player's position is reset when they fall out of the level bounds or they die. And then, like, add levels. Add and design levels. Play games for research. You know, Celeste and Super Meat Boy come to mind. You could add enemies. And adding enemies is a bit more complicated, but, you know, you've got this foundation, and I think you could then expand upon it from there. If you'd like to see a follow-up of part 2, I'd be interested in, we could do something with enemies, and sure, that's potentially interesting. But I think what I would follow this up with is making a 2D action shooter like Contra, or like Caro Blaster, if you've played that or heard of that, or Mega Man. Because a lot of this 2D platformer foundations, if we just give the player a blaster and enemies to shoot, like, we can make a whole new, type of game. So that's 2D platformer with Godot from scratch, from nothing to shipped game using public domain assets or Creative Commons assets with levels that we can build and design. Thank you so much for watching and following along. Let me know if you have any questions, and see you next time.